Hello everyone, welcome to my stream today. Just gonna get started here in a minute. This is a bonus stream. I'm still doing the stream tomorrow with Dylan. I'm looking forward to that. We're gonna get into building a language and look at all the things that go into that, from all the tooling, design, which I think is a really interesting topic because people see stuff like Svelte or maybe Vue to a certain extent, and they're just like I don't think a lot of people realize just how much goes into it, to consideration, from, as I said, from design to like prettier and code formatting and syntax highlighting and TypeScript. There's so many things. So I'm very excited to talk about that tomorrow. The thing is, the reason we're having a stream today is mostly we talk a lot about frameworks and reactivity, and Preact dropped some news on us. They've been hinting at it for like I'd say a couple months now about this really cool performance trick they were working on. But they actually dropped on us a new primitive to use with Preact, which are, well, they're signals, reactive signals, which, as probably to no one's surprise here, is kind of like an area that we spend a lot of time on the stream talking about. So there was just no way that I'd get away with not talking about that this week, and I'm really excited about the topic that I'm doing tomorrow. So I didn't want to like hijack the whole This Week in JavaScript to talk about Preact, because I realized there's a lot of prerequisite knowledge to fully appreciate what's going on. And sorry, before we even get into that, I probably should just share my screen for a second and see if you've been living under a rock and you haven't seen this. This is Jason posted this a few days ago, and Preact's adding signals, basically reactive drivers into their VDOM implementation. It's actually kind of cool, and we're going to talk about that a bit later, what that involves and how that works. But I think to properly get the context of all of that, I want to go back. And yeah, I apologize for people who just came here for the hot takes. That's just not how I roll around here. Generally speaking, every decision has a long history that led up to it and a lot of implications and trade-offs. And those are the kind of things that we look at around here. So again, I apologize if you're just coming here to get the hot takes, so to speak. Just a second. I need to close this down. We're gonna be looking at some other stuff. Yeah, I just posted on Twitter that we're live. I got to remember to actually post my Twitch link. It looks like people from Twitch are coming in though, so yeah, I'm glad about that. Yeah, I mean, I've been talking about these topics a lot recently. It came up in the 1.5 stream too, where people were like, push pull. What are you talking about, right? And a lot of these conversations are happening right now because things like this get released. I'm trying to remember. Let's see if I can find the conversation really quick here on Twitter while we're just waiting for people to join out. There was people are talking about these signals, and you know, obviously, like someone's like, "Whoa, React, are you all gonna jump in on and do this as well?" Just a second, I'm gonna pull this off here. But what I wanted to, let's see if I can find the conversation that I'm looking for. 2 seconds. Yeah. All right. Yeah. Here we go. Preact signals seem like quite a nice, but I'd really like to hear React team's stance on them, because surely they've considered those as well. It's not a unique idea. Solid has signals too, and I bet some other frameworks as well. Yeah, that's an understatement. We'll talk about that, but reactivity of this nature has been in frameworks for ages, and not just like niche frameworks or ones that I like to talk about that no one cares about, like Knockout. I mean like major, like, and I don't mean like RxJS like you find in Angular. I mean Vue has been built off this from the day one, and they're strangely silent in this conversation. I mean, not that Evan's silent, he's made some tweets, but I mean that people just like haven't recognized that this is not really new. And I think that's part of the reason why I want to talk about this, because there's inherent trade-offs and decision points here, and they're not necessarily what people lead you to believe they are necessarily. Double check on him. Maybe not. Preact build. Yeah, he's definitely in the circle. Was basically saying, yeah, React is an interest in this, which is basically what I've been saying in the last few streams. But Dan came in to clarify some stuff for us. He said any is an overstatement, but he basically React's already decided that this isn't approach they want to take. And he's like, from my understanding, this model relies on reading mutable values during render, which doesn't work for features we're building like transitions and suspense, etc. It appears that the primary motivation is skipping re-renders, and we have other stuff in the pipeline meant to address this in a way that doesn't break our model, but definitely curious how primitives work for Preact. And I think this is just good to look at and point out, because I agree with what Dan's saying. I think there's also other solutions to solve what Dan's suggesting they can't do. Like you know what I mean? Like, I think you can do the stuff that React does with reactive primitives as well. So it's not like, but I can definitely see that it's a complete change of model. So anyway, I just want to bring this out because there are trade-offs here. Like, Dan is also very right. And I think we need to kind of get a fuller perspective to actually be able to understand and make these kind of decisions for ourselves, to understand how to take in this information. That's what we're here for. Yeah, let's see how you all doing in chat so far. I got a few people saying hi. Yeah, what do we got? Some people are calling it. What do you have? Maple's calling his shot. Before you even go into it, I'm thinking now that signals are kind of awkward in React. You either get the full granular render or an entire component render. Yeah, we'll look at that. I want to get there ourselves and see what we think about it. Yeah, what are we gonna? I think the bigness is a piece of not understanding or not knowing about solid. Fair, or Vue, to be fair. Like, there's two different levels of this. You have Vue, which might not be doing some of the optimizations that Preact's doing, but like, there's no way you can't talk about VDOM plus reactivity together without talking about Vue. Like, literally, that's been the thing the whole time. Like, Vue is not always the topic of conversation on our streams. There's certain things in terms of values, which I consider the important part, where I align much closer to React. And I actually think this is kind of an interesting thing here, because I talked about this last stream. Solid was inspired by React, not as a way of fixing React, but I created Solid having one of these reactive libraries, and then we're like, oh, React has a lot of good patterns. We should see if we can incorporate that. So I actually push Solid to look and be more like React intentionally as a way of reinforcing good patterns. Whereas I get the impression from this API design and stuff here with the Preact design, which is very Vue influenced, they're more like, okay, we're kind of always pigeonholed as like React compat, smaller React. We want to escape out of that. How do we get away from React as much as we can? And we'll use reactivity, and we'll use like Vue style primitives. I think it's a really interesting contrast where Solid's reactivity shape is pretty intentional, because it values what React values. So this might represent a bigger shift long term than people might account for right now. So that's why I mentioned Vue and Solid, because on the extreme, if you actually care about granular updates, you want to get the full benefit of this technology, you use Solid. It's the only one that works like this. But if you want the DX and you want to like have that experience and simplify things, in the model a bit with reactivity, like, there's a trade-off there. It's not necessarily purely simpler, but it helps you model certain things perhaps in a less verbose way. There's already Vue doing that. So like with a VDOM as well. So just Preact is somewhere in the middle now, which is funny because you start at a place where you're like a React Compat considered almost like a mini React, and now they're actually pushing into this zone that's actually somewhere between Vue and Solid. I mean, we'll get there, but if they do, yeah, I mean, yes, I mean, but maybe I'm just not doing a good enough job of marketing. I mean, yeah. Okay, so I think I got some people here. I'm gonna try my best. Today's a hot day. This whole week has been super hot, and I was actually recording all day yesterday for my VConf recording, and it was like a bit of a sweat fest. Today's going to be no different, but we're just going to get into it. Okay, so don't mind my drink. This is sweaty one. The thing you don't realize. Oh, actually, I don't even have all of my lights on right now. Sorry, give me a second. There we go. Let's get some more lights in here. When you're streaming, you got like you're sitting there and you got like a bunch of lights shining on you to make sure it looks good. So it's like it's not just being in a hot place. I'm like sealed up in a room to make sure you can't hear the family noise in the background, and I'm basically have a bunch of hot lights pouring on me. So that's how this works. My wife was like, "Well, maybe you should just stream with your shirt off," and I'm like, "I don't know if that's going to really work with this audience." So uh, let's just move on. Okay, so how are we going to start today? Well, let's get started here. Because the funny thing is, we're talking about Preact, and we're talking about virtual DOMs and all this stuff, but there's a historical precedence here, and it all ties into actually state management too. But I'm actually going to start with change management. I want to talk about change management. And change management is like state management, but we don't talk about it as much because it's not the piece that people feel like they have the choice of choosing. Change management is essentially the mechanism underneath that the framework uses to do updates, right? And I'm going to take a simple example to kind of show you all like what I mean by this. Is the easiest way to put it. Okay, so I'm going to go in and pull up a solid playground. I think this is big enough. Where are we on size? Yeah, this is fine. You've all seen this silly counter, hopefully by now. Am I sharing? I'm sharing my screen properly, right? You guys are all good? Yeah. Okay. Good stuff. All right. Right. So I'm going to start the easiest way by just deleting all of this. Okay. And this is how I like to start things, because we're going to go back to the beginning. I'm going to let's start with something almost jQuery like, just to kind of understand the evolution here, right? So I'm going to make a button. We're going to remake that counter again, but we're going to use vanilla JavaScript to do so. And you might be like, I thought you were going to talk more about Preact. No, I'm sorry. We're going to actually start with vanilla JavaScript because this starts with fundamentals. And our counter starts with some text in it. Our button starts with some text in it, like a 0. And we need to append it. So what is it? Document.body.append. Let's just put the button in there. Okay. Sweet. We have a button. It doesn't do anything. Actually, hot reloading and stuff is awkward here, so I'm actually gonna do this. This is my little hack so that we don't end up with 10 buttons on the screen. Okay, cool. And then our button needs to do something, so we're making a counter, right? So welcome to vanilla JavaScript. This is how you could do stuff without a framework. Obviously, this stuff was, in some ways, has been here since the beginning of time, from at least from our perspective. But and yeah, actually, I need to coerce this into an integer. Otherwise, it's going to just append it on the end. Yeah, plus 1. But essentially, and be quiet, TypeScript. I think we got a button here. Yeah, okay, sweet. This is vanilla JavaScript. This is we just built the counter component. And what's cool actually, as I said, is in the past the APIs might have been bulkier to do certain things, but this doesn't actually take much code. It wasn't actually much more code to write this simple counter than it would be to like do something in a framework actually. So there we go. We've got our counter component, all right? And when we click on it, it updates. This is not terribly surprising, but there's a reason why we don't hold or stick with just this approach, because essentially at a certain point we actually want to be able to how should I put it? We want to be able to kind of not tie everything directly to the event handler, because like we want a way of representing statefulness, because we might have multiple things that change. You don't want to like have like a lot of repeat logic, like multiple clicks and stuff. And we decided that we don't want to be jQuery. We want to be data driven. Okay, but that you have some kind of state, and the view is a projection of state. React might have codified it, but this did not start with React. But let's take our example and kind of go a little bit further here. So I need a state variable. I'm going to use an object here because it'll help me kind of, I think, get through the whole progression of what I want to show here. But let's now make this count 0, our state. And now this will coerce to a string thing anyways. And it's not too hard here, but now when we click our button, we don't want to update the button directly. We want our button to, we essentially just want our button to go count plus plus, and then we want this just to update. As you can imagine, this doesn't just update, right? Like clicking this is not going to update here. So this is where the actual fracture of JavaScript frameworks actually started, because actually deciding how to update the text is what separated a bunch of the original approaches to JavaScript frameworks. This might not be the most obvious one, but it's funny because I feel like with something like Angular or one of those earlier ones, this is actually the closest way to model it. But one way we could update it is check if the state is updated, and then apply the change. And you're like, well, check. Well, that's kind of stupid, but sure. Let's just do it. Let's make a set interval here. Okay. P is not, yeah. Okay, so we got our set interval, and let's put it at a reasonable time. Well, not that reasonable. We'll do 1 second initially. You can see that isn't very reasonable amount of time. And in our interval, we want to check some stuff, right? We're going to be like, okay, well, we can set, I guess the easiest thing we can do, right, is just go document, so we can just take our button and go text content equals state.count, right? And if we do this, I mean, you can see there's a lag. I can click it a bunch of times, and then every second it checks the value and then updates the UI. This approach is called polling, and I wanted to show this here because this might seem kind of like really bad because it's not responsive, but it is a legitimate way one could approach this. So let's make it 100 milliseconds instead. At 100 milliseconds, it feels almost responsive, right? Like this is not unlike like some of the stuff around Angular 1 time period. It's not exactly correct, but I just wanted to kind of show this, to explain one way of you doing it. What's cool about this approach is that there is plain object. We didn't introduce anything fancy here. We're still just using the DOM APIs, and we're now just adding some kind of scheduler, right? Yeah, someone's mentioning this is how like games work. And this is what people might call a pull-based system in its purity, right? Because essentially, at a set interval, we check what the value is. The only problem right now is like the DOM's pretty efficient, so this is fine. So it's like checking it every time. Like it's like every second it's actually resetting that text content. I mean, you're not going to see a change in here, I'm pretty sure, because the DOM is not dumb. It knows it's the same value, but it is behind the scenes calling a DOM API to try and set it every time. So we can do like a little bit better. So we can do something like let's make previous state here and make it into an object. And what we'll do is we'll set previous state equals like a spread of state. I think just I don't know if that's going to be important right now, but we just want to clone it, and then we can do something because we want to do some comparison checks. We're going to be like if previous state dot count not equals state dot count. Now do this, and this is a subtle improvement here. Yeah, people are referring to this being like Angular's dirty checking. This is where we're getting to, because I could check the DOM. I could be like, hey, button text content, if your content does not equal state.count, then update. But the problem with that is then you're not just writing to the DOM, you're reading from the DOM. And reading from the DOM is dangerous because depending on what it is, the DOM might be like, oh, crap, I don't know what this is, or it could have changed layout, and it actually causes if you're not careful reading from the DOM, you can cause early paints and early layout calculations at least, which can cause a bunch of thrashing, and it's super on performance. So what we realized pretty early is it was better just to pull out a copy of the object to check against, so that on each iteration we can just make sure that we can check it in JavaScript without touching the DOM APIs. So now while we're sitting here, our interval is running. It's only checking JavaScript, and we're not hitting DOM APIs unless something has changed. Yeah. So yeah, I told you I was going to go deep here. I hope you all appreciate this. Is previous state like a VDOM? That is a good question, and we will get there. This is part of the thing I want you to understand at the end of this conversation, is that there are a lot of similarities between the different rendering techniques. There's a lot of ability to virtualize and stuff. Some people have even called this previous state like a VDOM, like incremental DOM kind of played around with this idea. In my opinion, that's not... What makes a virtual DOM is that the representation is a DOM. Like the thing that you store in here is a DOM representation. Whereas this is actually just a pure data representation. It's actually just a plain Pojo object. So this actually, in my opinion, is one of 3 different rendering techniques. And what's cool about it is with even a simple example like this, I can show you all 3 rendering techniques. So this is like Angular 1 days, right? This isn't exactly Angular 1, as I said. Angular 1 was a little smarter than this, but I wanted to show you. I want to show you basically a very simple look at what change management looks like. Oh, hey, Marvin from Preact here. Hey. We will talk about some Preact stuff more a little bit later in the stream. To be fair, I am going all the way back to the beginning. Okay, so hopefully good so far. You all are following me. Sorry, I'm in an awkward part where I'm covering part of the screen, but all you're missing here is literally like document.body append the button. So it's not a big deal. Well, that's the thing. I want to dismiss this. There's no such, I mean, from a practical sense, there's no such thing as magic. I mean, I know, fun police, but I want to demystify the whole premise of things being magic. I think there is a real concern or thinking between the gap between the conceptual model and the implementation. That's an issue. That's where magic occurs, when you can't tie those together when you look at something and you're like, I can't make sense of it. Some of that just takes education, and that's what we strive for here. But sometimes the gap is big enough, the abstraction is good enough, but maybe something like the escape hatches are reveal something that you don't expect, and then you're like, oh, everything's magic. So we have to be very conscious as framework authors, because we do provide escape hatches. We want people to be able to do what they need to get done, but we also need to make it work with our model. And I think this is what React has been struggling with a lot recently. Yeah. No, we're going to get to React. This is just the beginning. So enter polling, and I probably should keep like copies of these around in case I need to like come back to them. I've already lost my jQuery version, but that's fine. We don't really care about that. So let's duplicate this tab and hope that it copies it. No, it's not, because we're trying to be more conservative about this stuff now. So okay, so yeah, and be quiet TypeScript. That's fun. Why is TypeScript Oh, I thought I unchecked it. Okay. Okay, cool. So here we are. So now we are going to look again. We can do better than polling. So the first thing that we might want to do instead of polling is something that I'd kind of call like events based, because to be fair, we didn't have to go to polling. That was just like a really simplistic view of how we looked at things, and we could have done this a different way. So let's get rid of the set interval, because like honestly this is just kind of garbage, and just we're gonna call this function maybe update. I would love to call it render, but there's like a little problem with our playground. I have no clue why it's like this, but in our playground, render is like a reserved keyword. I don't know why they did something like that, but that's fine. We can keep kind of our code the same, but now this is really obvious, right? But if I just call update directly in our click handler, now we don't have to. We're not at the mercy of the polling. This is you can tell there's no delay here. This is way faster, and this is like, this did not take me much effort. Like, this was actually easier to do than the set interval. It's kind of like the obvious choice. Update the state, call the update function, and then the update function does the work. I wanted to show the interval first because it's an example of a pure poll-based system, where it's hard to call this push or pull. It's not like technically the click event's an event that's pushing stuff, but like this is very explicit. It's very manual. We're just calling update directly. But yeah, at this point, this is efficient, right? This is as efficient as our original jQuery version, pretty much. We pulled it out to a function, but this is relatively efficient in our single case. You can imagine though, if this scaled up, it might not be, but we'll talk about that more in a minute. Let's continue on our journey here. So, okay, now we're not polling anymore, so we're away from the pure poll-based mechanism, and we're just kind of calling updates as we need it. You can pretend everywhere you call state.count, you call update. And I'm going to fork this one more time, because I think this is actually the common base between most of the other methods. So someone asked me about React a minute ago. We're not going to get all the way to React here, but what we could do is we could try and shift this around, right? Now this is kind of like Svelte. Yes, actually, yes. This is Svelte. You don't see the update call, but the compiler literally goes there and more or less goes, oh, you did something, you assigned equal sign or plus plus, compile in this update function, and then Svelte keeps some bit checks for dirty checking, but they actually do something like not exactly this, but they do actually do a check in the component and then do the DOM operations directly. Like this is actually, thank you for pointing that out. This is actually a lot like Svelte. Okay. So we want to look at something more like React, and we're not going to go all the way there, but what I like about this exploration is you start like realizing things, right? Because on the journey there, you're like, okay, So the first thing to make this like React is you're like, I want to get rid of this update function. So what if we want to update our state here, but we don't want it to how should I put it? We want to call set state instead. And this is why I went with an object, because I think this will be more obvious. We want it to be like state dot count +1, right? And we don't want to update anymore. So now we can get rid of this. And instead of update, we're going to call it set state. And we're going to put in our state that we're going to pass in. And I know this is shadowed. Oh, it's funny. It's like I have to, yeah, okay. I know this is shadowed, but don't worry about it being shadowed that much. This isn't like real React, but I just want to show this kind of mechanism here. And now this looks the same. We clone our state into previous state. So now we can diff it. Okay, this looks good. Let's press it. Oh, it goes to 1 and never updates again. Have you guys ever hit this problem before? I mean, we know we're getting into React territory when we have this problem, right? To be fair, this isn't exactly what's happening with React, but I want to... The problem is this value of state is stale. This isn't like how React actually works, but it's actually kind of the same thing. And the problem is the state is in this closure that happens, right? Someone said unique classes. That's one way of solving it, right? And then you can reference it through this. That's a good approach. I got like a way simpler approach of way of solving this though. What if we just put it inside the set state function? Okay, whoa, just a second. Got to make sure that I'm doing this right. But if we put it inside the set state function, we should be able to, in theory, be able to close over the same state from the previous run of the state, and then we should be good. So let me see if I can refresh this. Okay, what am I not doing right? Because I would expect this to actually work. Let me think here. Oh, do you know what the problem might be? It's not initialized. You have to run this the first time, right? So what if we pass the original state in here? Because the click handler never was registered, right? So, and actually, since we're going to run this through the original time, we don't actually need to set this here anymore. And if I'm right, we should have our working button again. Okay. This is not React exactly, and I'll explain why in a minute. But you're starting to see the similarities here. We actually put the click handler inside the set state function as a way of basically invalidating the closure. We're recreating that closure every time, wrapping over the latest state. And we needed to run it once in order to initialize it now. And essentially, we're kind of starting the flow. The only thing that's different here is, see how the button's created outside? Whereas, and this is, you know, where the interesting part to reconcile it is. We're going to talk about why and how that impacts things a little bit more in a minute. But I wanted you to kind of get, like, you can see even with this simple thing that doesn't have a real VDOM, we're already getting into the zone of these kind of considerations about like when we're trying to run stuff and stale closures and constructing the object and stuff. To be fair, this is a single pass non-VDOM implementation, so that's why we're sort of hitting it. But it's also why there was challenges, like React introducing a VDOM like opened up a bunch of design space. Okay, so before we go forward, I want to show one more. Yeah, yes, this better explanation maybe for people kind of coming in. I want to show one more example based off where we did it, because we had Angular. Essentially, we have what became Svelte, but again, not quite it. And then we have something that's React-like. But again, these aren't completely accurate because there's other elements here. I'm going to take our svelte base one more time. Let's duplicate this, and we're going to do one more of these from svelte, and I want to take it a different direction, because if you remember, sorry, not there, there. If you remember, we're just trying to get rid of that update function, right? You can use a compiler to do it. You can kind of conflate everything to do it. Is there another way of getting rid of that update function? Right, we actually, and set interval is a way to do it too. I thought the VDOM was to avoid heaviness of doing that update to actual DOM objects instead of simpler JS ones. It's to guard it though, right? It's this part of it. Updating the DOM has to happen regardless. So it's more of like, if we can check the stuff ahead of time. But to be fair, dirty checking in Angular was checking the stuff too. You know, the idea was that I think it made it easier to do more complex things, like in terms of the diffing. You can actually get the full representation, and you don't have to rely on data as much, which is, it's going to come into play when I talk about the one more, right? Not updates to prevent reads from the DOM. Yes, and that is super important. That's actually where a lot of the performance is. But you can get that from having like these objects I showed. Yeah, mutating, then reading. Yeah, but when you get these in tight cycles, exactly. Yeah, exactly. Yeah. So good, we're all on the same page. So we're going to try one more approach here of getting rid of the update. And I don't know if anyone can guess what that other approach is, but I feel like if you've watched my stream before, you might be able to guess what that other approach is. It starts with putting the information in the data. So we're going to do something. There's different ways I could do this. But I'm gonna do like, I'm just gonna use a proxy because I can. I mean, we could use getter setters if we really wanted to, but the thing is, if we want to update and add more state, then there's more work there. I'm just gonna use a proxy because I can. So, well, this is a super simple example, but let's target property and value. Yeah, we're gonna change our state now into a proxy. And don't get me wrong, it doesn't need to be a proxy. It could be a function. It could be anything. But I want to use this form because I want to keep the look of our examples similar to each other. So we could, when we set our property here, we can just set it to the new value. But what we want to do is we want to call update, right? If we call update here, and then return true to say that we've written to the value. If we call update here, we don't have to call update here. And magic. So you guys are talking about magic. But this version is what I call the, I guess, basic reactive version, right? All we did was, instead of using a compiler, instead of kind of pushing everything in, we decided to just make the data special. We probably could have done this a different way. Like, let me think. Do we want to do it a different way? Let's play with a different way. Was it object? State could actually be a const here this whole time. I don't know why I didn't do that. Object dot define property. What is it? The object will be. Oh, I guess I need an object, and then get. I think get function or set function. Yeah, I just need a setter, I guess. Set. Actually, we're gonna set. I don't know why I'm being so slow here. We just need a set function. It takes the value and then basically does the same thing here, right? Or is it target value? I'm just not even thinking. You know what? Screw it. I'm too lazy to look. Should I look this up? I wanted to point out that this is not just like point out that this is not. Is there a simple example? Give me a set. I've done this like a billion times, but I'm like just not doing it right now in my head. Set new value, of course. Right. It's because I need to. I don't even want to deal with this. It's because I need like a reference outside of the object to set the object. Just screw this. This is why I went with a proxy. I'm saying you don't need a proxy to do this. Proxy is just like the lazy, less performant way of doing it. Okay, so we're going to move on from that. I just wanted to show, it could even be a lazy function. The thing that I want to express here, though, is this is not the full reactive story, because we're still actually dealing with state that is just read. You see I only intercepted set, I didn't intercept get. There's no automatic subscriptions here. In fact, none of these approaches actually deal with the fact that like these things can be subscribed to multiple locations. We just have this update function, this one centralized update function. And as you can imagine, that doesn't scale. There's gonna be a limit to how far we can take this update function. And what can we do about this? Well, now we're going to get into the Excalibur portion of this, right? What we can do with this goes back to those original frameworks. I just showed you a bunch of change mechanisms. And the prevailing logic back in the day was that we use model view controller, MVC or MVVM. There are differences between MVC and MVVM, but I'm gonna focus on MVVM because MVC in the client is kind of a lie. Like it was never real, which is actually what motivated a lot of the change from Angular 1 to Angular 2 and whatnot. Like the problem with model view controller is that, no, I'm gonna put model here, model view. Sorry, I don't know. View doesn't go here. View goes over here. It's funny. I'm going to put the problem with model view controller is that you have a bunch of models over here, okay? And I don't know what they're going to look like. They're like databases, but let's just pick a few models. I'll make 3 because I can. And they're kind of, there's no actual real hierarchy necessarily. They have relationships, right? We can be like, you have this and you have this, and maybe maybe this one also references back to this or something. Like we can make a bunch of relationships, but it's not directed. It's not like the model of like a UI. Whereas like the view is very much what shape do I want to use for the view? Diamonds? It doesn't really matter. The view is very much like, let's make a few of these. It's very much like my arrows are probably gonna be like the wrong way, but it's very much like a directed thing. Like this has these, this has these, this has these. It's very much like a tree. You have a parent element that has a couple children that have some children of their own, right? Everyone following so far, right? Components are how you feel inside. All right. I mean, this is what I'm getting to, aren't I? The problem is old conventional logic was on the server, and this made a lot of sense, was that in the middle here, and I don't know, we're going to use purple, we had the controller. And use effect is how I feel outside. Okay. All right. So we're still going here, right? So the problem with this model was that usually UI didn't really own the model. Like if you're in the browser, there's like this other hidden arrow going off the side of the screen going like, what are we going to say? Server this way, right? But the problem with the earliest versions of this model is that if the server kind of owns the model and the view has all this display, how do you like make view specific representations of data, essentially? Like, how do you get view specific state? And the controller was just like, look, I know that you have a user model. Let's go back here and pick color and be like, user, there you go. And the controller's like, okay, let's get him seeing. He's like, I'm a user controller. I know what to do with that. And is it purple? Yeah. And then somewhere over here is like, oh yeah, I display users. Like this kind of link up seems like it makes a lot of sense at first, except there's no way where to hold that state because they're like, oh, this user in this list is selected. Where does that go? Does that go in the model? No, that doesn't go in the model. So you might be like, why am I going on this crazy tangent? Well, the thing that we realized pretty quickly here is that there's this invisible other thing. And I say it was invisible, but sorry, I'm going to keep the controller hard, like straight line. But then I'm going to draw in this space another circle. And we're going back to Angular days, right? That's the idea here. I'm going to be like, there's this thing in here and it's called scope. All right. Oh no, scope. And this thing was really weird because it was a weird mixture of model data and like instance-based data, and it kind of got passed through, and it was a mess. Nobody liked scope. But before we got to React and stuff, we realized that there's actually another way to solve this, right? You got to remember, I showed you that React model. The problem with the React model here, which is, this one, is if we want to break stuff up, we actually need to pull this inside the set state function, and that's prohibitively expensive because you don't want to be recreating DOM elements. I hope that, I know I haven't fully explained that, but I'm getting there. But before we get there, we were like, okay, let's just change our plan up. Let's make these view models, and now we can just do this, and we can have as many of these representations as we want. And if there is something like, I'm trying to think of what's a good example to put in here. Like, this is a user. Let's say these are friends. This is like a friends list link table. So that's why it points back to users, because there's like this. And then let's say this is, what do users have? I don't care. They have addresses. They have cars. I don't know, whatever. Let's say they have addresses. I want to use addresses because multiple users can share the same address, right? But essentially, we can have multiple. We can have a user per actual user. And yeah, I didn't pluralize this. That was my fault in the beginning, because generally speaking, the database is a collection, right? So users, friends, addresses, and then you might have user, 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 and you might have get there. We can do not friends, because users are friends. We can do address. Okay, this is a little bigger. Yeah, okay. Now we have address, and we can have a few addresses. Notice that friends isn't even really represented here. It's actually, like, when we get to here, what we'll see is that the friends relationship is actually like a is actually an arrow. Like, that's the thing. And then these users have addresses, and it's funny because these arrows can still point back, right? Like they can still be directional. And who knows, maybe this user has 2 addresses. But it's like a slightly different representation because it might hold. Well, here's the challenge. Do you map your this is the problem here. Do you map it more to your model structure or more to your view structure? Which in your view structure you might have a user, so you have users list user, or let's say you have let's show a user and then let's show each of their friends, which are another user, and then we'll show their addresses as like another piece of it, right? Like you can see that this actually resembles this a lot, but it can also resemble this. So I just wanted to kind of point out that there is a very easy way to keep things separate, and this is what we used to do. Because going back to our reactive example, or really most of our examples except for what I called the React example, you notice in the React example we called set state right at the beginning. We ran it once to set everything up. Whereas in the rest of these examples, there was like a clear creation and a clear update. Whether it's the reactive or what we called the svelte example, where we just did the call to update explicitly, there's this clear create and update. And what it works kind of nicely with this kind of drawing because you have this model, this exists somewhere else. And then when you go to make your kind of view representation, you just, you just make everything once. So you create it, and then when you go to update it, well, you update here, or maybe models. It's unclear exactly. It depends on what the thing is. But if you click some part of the UI, you're going to send your updates back this way, right? Here's an update. I should change the color of that arrow. It's something more punchy. There we go. And you're like, okay, I'm going to update this. So I don't know why I'm pointing from there to there, but let's go from address to address, okay? So now we're doing updates, okay? Update this address. You click on something, triggers this view model, update, and then we're back to our change question because we called the update and then we're like, how do we get the change back here? So click something in the UI, doesn't have to be from the address, and then reflect it back on the address change. And yeah, let me call it change. Okay, this is what we've been looking at this whole stream, basically, essentially how this kind of loop works. And it might sometimes go back to the database model because it feeds in, but it's very easy when you have these trees that create once and then they're very directly linked to be able to just do these updates. And this is basically the state of what the world was like before React. And I mean, to be fair, in a sense, Solid today is still a version of this. I mentioned earlier that there's 3 types of rendering, and the one thing that these days we all have in common isn't this, because no one actually does MVVM anymore, because what React did is they introduced the component model, right? And let's change this to the component model so that I can make this a little bit, not that. Let's change this to the component model so I can make this a little bit more obvious what we're doing. Okay, actually I want to get the server this way in here. Okay, this one here is black MVVM. I don't even know how to make text bigger in Excalidraw. I've been using this for like over a year now, and still not master. Okay, let's do this. Okay, so what did the component model do? Well, it can collapse this, which is like, and that has some coolness here, because now these sit on top of each other. And you're like, okay, cool, sitting on top of each other. Well, I mean, that's a bit of a mess. So it didn't collapse it like that. What it actually collapsed it like was more like this. I'm gonna just have to delete all the arrows because I don't feel like working through all this. It made the decision. I told you earlier we couldn't make the decision here between whether the view model should be more mapped over the model or mapped over the view. And well, for a lot of you, you might be like, what's the big deal? Well, the problem is you want your code to be dry and reusable. So there's this huge temptation there. Like, I'm always just mapping over the same fields, right? To get that data. And especially in our reactive example, we're making proxies, we're making actual, things like you pretend this part is our model or something, and this part is like our reactive data piece. It's kind of tedious to go through and like map it all again. You're like, oh, it's the same code. Why can't I just put them together? The problem is this is a mistake. If you bind these too closely, you end up in a zone where you have a bunch of extra fields on your view model that apply to certain view pieces and they're not shared, like selected state. You're kind of back to that old MVC model and not realizing it. So people who use this pattern kind of had two types of view models. They had like model view models and view models. And it worked, but React was like, screw this, right? It was just like, no, not happening. These two go together. These two go together. Why are we separating these things? These might be different technologies, but these things do go together, and these things go together. And I mean, sorry, you guys get deleted. But now, in our new happy home, we have components. All right, welcome to components. This is great because now you've sliced stuff. You've sliced stuff like a different way, right? And these pieces are definitely more addressable than whatever giant trees these came in. Because if you never worked in a code base like this, like everything became folders of, like you had two different, like there's a whole question of how you actually organize your code folders, because you'd be like, you might have like a view model folder and a view folder, and then have two completely separate trees of files, which was really hard because you're like, okay, where does this user data and the views way over here? Okay. Sometimes we actually co-located our folders. Like we're already getting here, but you were kind of like in folder land, like where you had like view model.js, view.jade. It's like naming a folder convention where you like pick like some generic name like index or template or style, and you make three files in the same folder. Actually, it's kind of like SvelteKit's new routing, or the Next.js new routing, where you have page layout error. Like that's basically what we were doing here. And this was just like, screw this. We're going to put this together as the same technology. We're not going to worry about that. Okay. I mean, so far you're all like, wasn't this stream called Components or Pure Overhead? What's going on here? Okay. Well, we're getting there. I told you this would be a long journey. Let me drink here. All right. So this is all fine. And the reason I wanted to do this illustration at the beginning here was because the problem with this model is, it's not a problem, but the first challenge you face is this. When you add a new address to a user in this model, in this old view model, you do change, like we talked about. Like this is still kind of like a global thing. Maybe you ran it once to set it up, like we showed, but then you go, okay, this user changed, they got a new address. So you add it here, the data changes, and then the view checks and goes, oh, user, your data changed. We need to add this new address here. And at that point, it's clearly an add operation. Like it's clearly, no, not that. Sorry. It's clearly an add operation. It's clearly, like, let's create a new one of these and wire it up. This is a little bit more interesting when you combine it together, because we've kind of killed the separation between create and update. By like, there's probably ways to get it back, but generally speaking, when we add that new address, we're going to basically make a whole nother one of these, and the creation and update logic is kind of locked together. And we don't want to recreate stuff every time we do this. For something new, it's fine, but when we update something, we don't want to recreate it. And this is sort of the challenge here, because this button is still a real button. If we tried to pull the button in to our set state function, it would be really bad. Like recreating the button every time. Don't want to do that. So that's why we got away from this. This first version, the dirty checking version, whatever you want to call it, had a previous state. So essentially, it would check into state. Whereas something like React, I'm not going to change the code here because it gets a lot complicated. I'm not going to actually make a VDOM here. But something like React, what it will do is when you call your component function, and if you've never seen this, do check this out. There's Hyperscript project still exists, I believe, and it's basically the foundation of our VDOM stuff. Essentially, you can describe elements as function calls, and you could, if you pass in a function as a first argument, it's the component. This is what React and Preact and all the VDOM libraries are built off traditionally. This is a function call. It doesn't matter. You return an object essentially that instead of it being the state that you're getting here, you end up with an object that represents the DOM. So we can pull button in if instead of calling document create element, we call like VDOM create element. Now we can do this. I mean, our example is not going to work right now because I didn't implement it, but now we can pull it in to our update function. Again, these simple examples are limited because I'm still treating this all as like a single set state. What we actually have to do is decouple the set from the read, which is more complicated than I'm going to be able to do with a simple demo. But my point is, for the simplistic sake, you can see that if we don't take the cost of doing the DOM operations here, and instead of this being now the button that gets its text sent isn't actually a real button, it's just a JavaScript object, right? If we do this and we return our VDOM, like you can picture each cycle, it's like a new VDOM, and we return it. We now have we can basically do the work once to update things, and we might not even actually bother with this check anymore because we don't really care. We might just like kind of go, oh, let's just create the thing, and then down here we'll have a second function called patch, which will take the old VDOM, or take the new VDOM, take the old VDOM, and actual like mount element or whatever. Like I'm being overly simplistic here, but my point is now in here we can go, oh, does new VDOM dot button dot text content equal old VDOM, right? If equals old VDOM, and only then do we, from somewhere from our like actual real DOM elements, like I'm assuming we've walked through here somewhere, like I'm oversimplifying this, but only then do we actually set the new text content. I hope that makes sense. In a VDOM library, we've actually separated this into two passes. A first pass where we actually run through all our state updates to generate this virtual representation of the DOM. And then a second pass where we actually compare the old and new versions of that representation to actually do the real DOM updates. Okay. But by combining this all together now, we've escaped our problem. We've suddenly opened up this world of components, because now we can co-locate all this stuff and just run it and not worry, because an update and create are basically the same operation, especially in here. In here, we don't care. Here, we'll have to do like, oh, does that DOM node exist? It's going to have to do a little bit of work in here. But for our state updates, it's just like, just give me the next thing. But that's the React path, right? But here's another path here. Let's talk the reactivity path. What if, like, there's another way to do this too, right? More granularly. I mean, the easiest way for me to do this, although this is kind of like a bit of a cop-out, is essentially replace our state now with const state set state, whatever, equals create store. This is just a proxy. Count 0, right? We can basically do this, and then keep our button, sure, and then essentially create effect, and we'll import that from solid, create effect, and essentially do something along the lines of, I mean, I wanted to show you all like how directly this maps. The previous state isn't like, I think I can just copy this straight in. Do I need to? I don't even think I need that. Still work? It's like, what am I not doing right? Create a button. Oh no, it's this doesn't work. What do I do? Set state count equals state dot count plus 1. Bang. Right? So I'm just very quickly showing, like, our original update function can go both ways. It can map to this systematic way of handling things like a VDOM does, where you're like attaching everything, creating the virtual representation, and then diffing it, or it can basically map directly to an effect, like a reactive effect. I'm not that ambitious, but you're right. I am trying to show how every JavaScript framework works. I don't think I have time to do that in one session, but you know, I'm trying my best. So hopefully this still makes sense. My biggest concern with the stream is that I'm going to lose people as I'm going. I've tried to do it in parallel in stages, but obviously my VDOM version is broken because I wasn't going to pull in a real library to do it. I did install it really easily because it was easy for me to display it because I'm in Solid's playground, but it doesn't mean Solid. I could have pulled in Preact Signals and done the exact same thing. You don't, like, as you know, all this means is you can already see the difference in philosophy here, right? Like the work that is the baseline of what has to happen for this two-step process versus like the work here, which essentially is just like call the update function whenever state.count changes. That's what's happening here. Okay, so awesome. All right. I've shown multiple ways of doing this. What this actually comes down to, even though I didn't upgrade the original version, is to this day, there are basically 3 different approaches to rendering. Forgetting about like Svelte's compiler trick or whatever, those three approaches are what I call one pass diff, which is like what we started with here, which is kind of like this, what I call the svelte version here. But it's also the way that tag template literals work. Like if you use the library lit, it works this way too. They can use components to hide like the update function or compilers or what different ways like reactivity to hide it. But essentially the premise is that you keep the previous state as some kind of state, and then you do this kind of diff of it, and it still kind of runs in this kind of top-down way. Then there's two paths, which is what the way VDOMs work, and two paths basically creates the. It's funny, I put the previous state here, but the previous state is not necessary. I guess it is here because you want to kind of feed it through the system again, but. Okay, never mind what I was going to say, but it has two passes. You create your pure function, it's called, where you transform the old VDOM to the new VDOM, and then you do all your side effects in this patch that happens later, okay? Like, this is really an in-out kind of function. It's secretly, even though I'm calling set state, it's secretly a function of VDOM and new state. Like, it is a kind of a pure function that returns that. This shouldn't have side effects. Those all happen here. And then there's the reactive approach, which again, look, there is a previous state here, but it's scoped specifically to each granular event or effect. So, there's actually a lot of similarities between this and the dirty checking version. The biggest difference between dirty checking and the reactive version is the granularity. All right. So, this is my technological introduction. I want to talk a bit now about how the impact of these decisions. Okay, hopefully everyone's still with me. Yes, it is also a function of previous state. Okay, so I actually spent some time trying to understand the differences between these rendering techniques. And the thing is, they are all super performant because at a base level, they all make sure that only the text in that button gets changed. You might be like, oh, well, isn't a VDOM really expensive when you show me that does all this extra work? But like when I did this article a while ago, this is like, when was this? 2019? Okay, May 2019, so like over 3 years ago. I was like, okay, what if I could take lit? And I was like, I wanted to see if I could compare based on syntaxes or different writing styles, approaches to kind of figure out what was the best way and fast ways to render the DOM. And if you look at this, there's incredible performance coming in. Like using Hyperscript with Solid, for example, is not a good idea because it does a bunch of extra creation. Solid doesn't like that because a reactive library, if you can kind of already see this, reactive library takes its hits every time it needs to do another one of these or another one of these. So it takes a different approach. You don't want to like recreate everything every time because these are what's expensive. Whereas this, the VDOM is just a plain JavaScript object. You'd think maybe something like this might be expensive, but in practice, it doesn't actually end up being that expensive. So this kind of rerun approach works really well for virtual DOM libraries. And that's why like call it as a function works really well for Hyperscript and stuff. And then what else did I look at here? Did I just skip through? I looked at compilers too. Tag template literals. You know what? This article probably isn't even the best for this, but what I wanted to show is that ultimately, after doing all the work here, putting them all in a single chart, there's a lot of noise here, but what I wanted to show is Solid Signals, which was a reactive library, was really fast. DOM-C is a dirty checking library. It's also basically the same speed. And at the time, the fastest VDOM library, Eevee, was here too. All of these approaches, if you've ever seen JS Framework Benchmark, if you ever seen this thing, there's like a giant table and it has all the frameworks. If you want to start getting into like over here, where's like, Where is React? React. It's got to be way back here somewhere. Okay, perfect. Like this, like standard, a lot of the standard, like React's like 1.8 here. This is not, the technology here is not the limiting factor. Like you can have a VDOM library that's basically 10% slower than vanilla. So I want to just highlight the raw performance numbers are not going to be the differentiator between these different passes. What was more interesting to me, because I did a lot of experimenting here, was not how fast like these individual techniques were, because yeah, VDOM is plenty fast. What's more interesting to me was this, which is the cost of UI components. Because essentially, I was like, what happens if I take this stupid example and make like every cell into a component and go crazy on it? And one of the earliest tests I did with it was like, okay, well, let's compare vanilla version to something written with web components the way that I'd write React. Not a crazy amount of components, just the way you'd write like a typical app where you'd like maybe make, if you've never seen the JS Framework benchmark, it's just a table. Who knows? I might even have it open right now. I use this thing like all the time. Let's just, yeah, I don't have it started. Give me a second. Let me just show you JS Framework parameter. Okay, let's just start this, npm start. Okay, port 80, 8080, beautiful. It's just cute. It's just, this benchmark just creates like 1,000 rows. You can highlight stuff in the rows. You can update every 10th row. You can swap some rows. See that one that's highlighting is being swapped. And you can remove a row or two. You can add 1,000 rows on the end. If you go all the way down here, you'll see that there's like more rows, we're in 1,200 now. And obviously you can clear them. These are just very basic CRUD style DOM operations, okay? So this test is not real world. It's just showing you how to handle lists. And lists are important, and I'm going to get to that in a second. But I wanted to say, like, initially you might just have a one component per row, a component for the app, maybe some buttons, simple implementation. But I was like, what happens if I just made every cell in the table a component? Like, what if I tried to make more components here? As I said, you can see immediately that web components have overhead compared to just using straight vanilla DOM. Like, just there's just a cost to it. And I didn't really test web components. I go back later, 2 years later, and I actually tested web components and show that, ironically, front-end frameworks actually scale better than web components. But that's kind of aside from what we're talking about today. What I wanted to do was take these different rendering techniques, like I talked about, VDOM, lit, which is like the top-down one-pass renderer, VDOM, which is a two-pass renderer, solid, which is a reactive renderer, and svelte, which is like a compiled one-pass renderer, and see how components, see how scaling the components affected things. And here's the headline. I could throw as many components as I wanted at a VDOM library, pretty much, and it would barely touch. Look, 1, 102, 104. You can't even tell basically whether I go between 1,000 and 5,000, or I guess it's like the 10,000 row one is the difference between like 10,000 and 50,000 components. It's like 10 milliseconds difference. And I don't know if React scales that well, but I just wanted to actually point out that conceptually, VDOM component scaling is not actually a consideration. They actually scale pretty well. Memory goes up mildly by the end. I understand this is like an insane amount of components, but it's actually pretty respectable. The one-pass renderers actually had some big performance issues as I scaled up the number of components. This is lit, and memory started getting worse. And let me skip solid. And this is svelte. Not as svelte as lit was, but there's this kind of characteristics. Felt actually had crazy memory degradation, even more so than lit. And what these libraries had in common was, see, React has components, and the components, as we saw, are basically just objects. We just generate all these objects. But the one-pass renderers, their components were like they contained the information they needed for like their reactivity. Like it was key. The number of components actually changed the amount of overhead they had, because a reactive system, like you'll like create an effect, or you'll like update stuff at a certain granularity, a certain scope. So they would like Svelte is a perfect example of this. Each component can re-render independently of the tree, so they have code to do that. It's like they wrap each component in effect, right? And that's why they ended up scaling the way they did, because essentially they would have to, like, the more components you had, the more overhead you'd have. Whereas, React, the components are just like more of the same. Like ultimately we were producing the same amount of DOM elements. Like it was just like an extra object. There's like a bit of a memory hit, but it was almost nothing. And you guys are going, okay, what about Solid? Well, Solid didn't quite scale as good as the VDOM. You can see that the last one's was 0.5 instead of a 0.4. But the memory was flat, basically. There's like a little up here, but essentially the memory was completely unchanged, whether I had 10,000 components or 50,000 components. And you might be like, what? Well, it's because if you think about it, a reactive system scales on interactivity, not on the number of components or DOM nodes. Like the number of create effects doesn't change given the number of components that I have. So in this case, we both scaled really well, because React's components or VDOM components are basically lightweight and they're not worth anything, and Solid doesn't really have components. But the one-pass renderers that did conceptually have components really took a hit as we scaled them. And this is where it started for me, because I at this point, I was a web component guy. The reason Solid didn't have components was because I was like, oh yeah, you'll just use those web components. And then I was doing this studying, I'm like, crap, web components don't scale. I mean, they scale fine, but they don't. This is benchmark, like armchair benchmarking. Like, who puts 50,000 components on a page? I don't know, but like they were clearly a visible overhead, and I was like, React's got this right. And I'm like glad I did this test, because Solid actually, I guess, has it right. If I like, this is the moment when I decided to embrace like no component, or the component overhead thing, because I basically said, like, I'm going to make a bold statement here for the non-virtual DOM crowd. I think components should vanish in the same way as frameworks. If the new world is compilers, we can do better. We can optimize along bundle chunk lines instead of ES modules. If components are throwaway, think about how much overhead we could reduce by inlining them right in the right scenarios. If components aren't necessary mechanisms for change, like in VDOM libraries, what is to stop the level 2 implementation and above from being compiled into the level 0 equivalent? Like, why should there even be levels here? Like, why should, like, because this chart shows like everything is like the normal way, then add some components, then add some more components. That's how the scaling works. And when I went back to look at the real cost of components much later, when I looked at the VDOM one, and sorry, give me 2 seconds here to kind of show what I'm talking about. When I went back to look at the scale here, was it cost? When I went back to look at the scale here, I didn't give Inferno a free lunch. Instead of making level 0 their optimal thing, I actually put the whole app in one component. And what ended up happening is with the VDOM was the slowest when I put the whole app in one component. And you might like be thinking, okay, well, why is that? It's funny though. Once we go to the next stage, and I add more components, the VDOM suddenly jumps ahead of the single pass ones like Svelte and Lit. And ultimately, by the end of this whole process, when I get to the last version of the table, Solid's faster than Web Components, and Inferno is basically right up there with Web Components, and these two have kind of dropped off the end because the component scale. Now, again, this is a stupid test because I'm putting a stupid amount of components on the page, but I wanted to kind of emphasize that this is just talking about creation and update overhead. There's other places where the cost of components is a real thing. Because, sure, but let's go there for 2 seconds, because the place that comes to mind is, sorry, not that article. That's the namesake. I mean, we can go here, but I want to go here first, and here. You ever seen this article, Hydration is Pure Overhead, from Miško Hevery, creator of Quick? We talk about a lot of the cool stuff Quick does, and he codifies what a framework does in terms of talking about different kind of state management and talking about what needs to run with hydration. But the key part about this is is that this resumable place, like forget about lazy loading, is about being able to not run the component again on hydration. And if you looked, we've sort of priced ourselves into running the component again. Remember, the second that we went to that model where we called set state at the beginning when we loaded, we're kind of in that model. If you do look, some of these other models could just skip this if they're not hydrating. But the problem is our hierarchies are trees. We've gone to a component model like this. So to get from A to B to C, we actually need to run this whole tree, and these are tied together anymore. We can't. Back here, we could go, oh, maybe we don't need we could just run part of the tree and not the other part of the tree. But now, these are together. We can't separate them very easily without a compiler, and that's a point he's making. And if you look at how Quick works, or resumably works, I wrote an article on this a little while ago. But what I showed was like a normal component, our counter, like we've been using this whole time, right? And I asked the question, how can we start this component without running it once? Because count is tied to this instance of counter, and if we want to wake it up on click, we have to call set count and use count, and if that count hasn't been instantiated, how do we do it? And I showed an example where you hoist everything and break it apart again. Presumably you do this with a compiler, but my point is the granularity of change has to be subcomponent if you want to solve this problem. You need to actually not rely on the component update lifecycle. And I'm not going to get all into resumability in this stream. I've talked about it before, but I want to point out that this is another place where the cost of components is actually a real one, right? So I've talked update performance, I talked about hydration performance. Someone's asking about this. Yeah, Solid actually fakes components during dev to make it easier for dev tools. Don't get me right, wrong. I want to author components, and I'm actually going to pull up the quintessential article, I guess, for this stream, which is the namesake, Components are Pure Overhead. I don't know as many people read this as my original Real Cost of UI components article, but the thing is, it was based on Rich Harris's Virtual DOM is Pure Overhead article, right? And I want to talk about this because he showed this example, and this is getting back to why putting Inferno in one component is slower than putting it in multiple components. This is the whole change management problem. He gave this example about where is it? Somewhere down here, where you basically have a list and some state for whether the item's selected, and he was suggesting that every time selection state runs, they end up like rerunning the whole list again, because this is just a function. I mean, it's easier to see this with hooks, though technically this has always been the case with React. like we're showing, even if you update something that's unrelated to the list, this one is in the list, but even if you update something unrelated to the list, in this component, the component will rerun. The setter is like tied to the component. And funny enough, that is true of Svelte as well. So I found this like a really interesting article for Rich to point out, because under the hood, Svelte is actually the same. Svelte splits the update and create code in their compiler, but they still have this rerun the component model. And sorry, not this one. Did I? Yeah, okay. What I suggested here is that any real VDOM would separate the rendering. Like you would split this component into multiple components so that you could isolate the updates. That's basically what you do. You can wrap it in a memo or use memo, and suddenly you don't have to redo a bunch of the extra work. You just have to tell it when to memoize, which is a challenge in its own right. But what I was trying to point out in this article here is that reactive libraries are pure overhead too, in that they don't scale as well on components, because the components are the thing that carries the, if they're component-based reactive library, are the thing that carry the weight. They're the effects. They're the observer, and this is a difficult challenge to balance, because if you have, and you see this often with, like, I think single file components actually work really well for Svelte and Vue in this case, because you tend to build larger components with those libraries. Right? Like you just put more in your component files and it works nice. It's a really nice layout, and you just set some state at top and then you build it. Whereas React, you're much more likely to break your component into like smaller pieces. Like you're like, oh, this is a function, this function. You just kind of compose it that way. And in React, you get benefits. The more components you make, the faster, the more localized the change can be made. But it's a weird contrast, because it puts VDOM and reactivity naturally at odds, like they were right from the beginning, right? Rerunning everything, right? Trying to figure out a way to combine the create stuff in here without a cost. And here, this is leveraging the fact that it only runs once. So yes, reactive libraries do not need to hand optimize re-render, because they're already memoized, but I'd argue they're over memoized. Like some people did a study where they're like, oh, actually using use memo here isn't worth it. Right? Like I forget the article, it came up a while ago. Someone was like, yeah, don't overuse use memo, because that has a cost to it. If you memoize everything and it's not that expensive to calculate, you're actually making your app slower. And in a sense, most reactive libraries generally memoize everything. So like you're almost immediately taking on that cost. Sure, the updates are fast, but the creation gets hit. And there's ways to mitigate that. Solid actually, key secret here is, while it tries its best to keep things relatively granular so we don't take component costs, when we see stuff that's around the same area that needs updating, we actually group them back together. I don't know if anyone's ever seen this. If they look at the source code, we actually group effect updates, because we don't want to create like 10 effects. It's actually like whether you update 10 things independently or run it once and do a shallow diff, probably worth it. The problem with the grouping everything at a component level is the problem that we were showing here, like where you're like, oh, well, you update the component, now you have to update the list, or you have to do list reconciliation. In Solid, we separate things along children boundaries, essentially, where insertions happen, but we group element updates. So the heuristic lets us split in the way that's logical for the structure of the code, rather than the way the end user splits it into components. So it's not just pure fine grained. Someone asked me a long time ago, like, why is Solid so fast? It's because it updates everything separately? No, hell no. That's actually bad. Like you have to do this in a smart way. If you just make everything fine grained, sure, you get these really fast updates, but you've actually caused the rest of your app to slow down. You got to be, there's a balance to be struck here. Yeah, exactly. Right. So this is kind of like where I'd kind of gotten here, because I decided that really components were the enemy, and I mean that's such a weird conclusion to come from when we live in this world where everything's written in components. I'm not saying don't write with components. I'm just saying that the components aren't how should I put it? Like, they aren't necessarily the right boundaries. They should be for you. And one of the coolest things I loved from using Vue or Svelte is you didn't really think about the component boundaries from an update structure standpoint. You're just like, oh, I'm just making some code, and you weren't worried about, like, with React not making, or VDOM not making the right component boundaries actually is a real performance hit. Like real in the sense that I talk about real. I'm sure you can just not bother, but you will re-render too much. Whereas, like there's whole articles on it. Like one of my favorite ones from Dan Abramoff. What was it? When to memo. Can I find it? This is the actually use React memo wisely thing I was talking about. But maybe I just go to overreacted.io. Before you memo, there it is. This whole article is talking about how you can avoid using memos, but using the structure of your code to basically get benefits. Right? Like talking about how you can move state down, lift content up. These tricks are better optimization than any kind of construct that you can build, like you use memo or whatever you can use in the framework, because they actually just alleviate the problem without having to rely on like these kind of special hooks or actual memoization. You're actually using the structure to memoize for you. So, okay, a lot of stuff to unpack here, but this is just where I'd got into and really informed the design decision of Solid, because again, I probably wrote an article about this at some point. I've got lots of those. What is it like? Let's try the word fast, or maybe performant. Is that a good keyword? Performant. Maybe it's on the next page. I wrote it a long time ago. Thinking granular. How is Solid so performant? When I actually went through this whole thing, I was like, oh yeah, it's because it's reactivity, silver bullet. And like, no, it's not reactivity. It's because of careful things. First of all, compilation to actually clone the nodes on the DOM instead of like doing like hyperscript style like per element creation. Nice chunk of performance improvement because this lets us compensate for the fact that our reactivity is more expensive than just the plain objects that you find in a VDOM, right? So one way we can leverage is we know our stuff's going to run once. Why don't we just optimize for that? Use a compiler ahead of time to do that, right? So this whole cloning nodes kind of mechanism, right? But it's more than that. We can analyze how to group effects. We can basically figure out how to come up with an optimal thing, right? And this is what I was talking about, like loosening granularity. Like, it's not just about that. One of my favorite ones that people don't realize is around computations, computeds. We call them create memo in Solid, but people have this tendency to overuse computeds the same way they have the tendency to overuse memos in React, right? So your first temptation is to do a create memo, and then now I've calculated full name, but like full name is not expensive to calculate. You'd be better just to put it straight in here. And this seems like a weird thing, but this was a huge design consideration for when I built Solid, because I wanted to make sure that people never felt priced into adding reactive wrappers where they didn't need to. Because this is like places where you get caught, because most of the time people use Solid can kind of ignore create memo works and this exists in the same way they use memo. They can just go, oh yeah, I'm just gonna wrap this in a function. And the fact that create memo is a function and that this is also a function and signals are a function and everything is just a function means that we don't need to do anything special, right? Like this is one of the reasons that I never did something like dot value in Solid, because people will be like, oh, how do I pass this API through? What should I do? They're like, what's the easiest way to make something a dot value? Well, I'll wrap it in a computed. But like a lot of APIs, like in Solid, I made it purposeful that you couldn't tell the difference between a signal, a computed, or a regular function, because I didn't want people to rely on that. And because if they relied on that, they'd have a tendency to overwrap. And if functions just work, then there's no tendency to make too many reactive variables. You don't need to. And I think this is a really important part for performance design, for dealing with reactivity, because reactivity, while it's the powerhouse that lets you do the fine-grained updates, it's also your biggest expense. And it's a very hard thing to balance, right? And again, I'm getting a little preachy on Solid side, but this is all going to be relevant in a minute. Should full name be full name in the second example? Honestly, they could both be function calls. I am sort of, I don't know why I did it this way. It doesn't really matter. Solid will unwrap the function. I hate that we do this, but it will for these, like, so you don't have to do it, but please do it. It's a better convention. These full names should be function calls. It won't do it on attributes, but it will do it on inserts. It's a terrible inconsistency, but I need it in order to handle dynamic components. This example's bad, you're right. I should go back and add the function calls. Yeah, sure. But I mean, it's literally the result of creating a system where everything has to run top down over and over again. Whatever mechanism you use to compare values and memoize, you still need to memoize, and you need to check those memos. And the bigger the granularity, the more diffing you have to do. Okay. So we talked a lot about rendering here, and this the costs and trade-offs. But I'm going to take this. There's one more thing that I didn't talk about before we actually kind of apply our learning and thinking in practice, is that lists, like the thing the JS framework benchmark tests, like when you have a list of users or a list of to-dos or whatever, this is the one place that all the frameworks actually are very, 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 very similar. I know it's kind of weird because when you see reactivity, the first thing that comes to mind is you're like, oh, if I push to this list, then it should just push to this DOM, right? You kind of have this picture in your mind where like the proxy, where you're like reactive state, right? Not reactive state, and then you're like DOM, and you're kind of you picture like if you could do something, right? You could be like, you perform an action, and then the same action comes out the other side here, and then you do another action, ching, and it comes out the same side here, and you're like, yeah, sweet. So if I unshift and then unshift and all this stuff, the problem is that when you have an atom, when you have a single piece of state, and it replaces itself and it runs, like you're in pretty good shape with this. But lists, the problem is you want to at some point actually batch multiple updates. Like you don't want to like do like one then one then one then one. You're like, okay, let's these things are related. They affect the view in the same area. I want to actually put those changes together. And the challenge is that for an atom, it's just an overwrite. You can just go like, okay, I have a pending value. I'm just going to overwrite it. So like you can picture a scenario where you're like, okay, I'm just going to make a new playground just to kind of say this, but you can picture like, just ignore this, but you can go like set count to 1, and then sometime later you go set count to 2, and if you batch it, it's only here that it's going to do like, oh, count equals 2. Like you know that the work is going to get done at this point with count equals 2. It's never even going to see the 1. But the challenge And this is done because you can simply just overwrite the pending value. But if you're trying to propagate fine-grained changes to, say, like an array, you know, now you're in this thing where you're like, okay, array dot push one, array dot unshift something. You have to encode all the steps because the order matters here, right? When you add something or remove something, like if unshift happens before push, I mean, that's not a great example, but like insert, like you might insert at the wrong index. Like it actually matters what the insert at index 1 some value. Okay, let's pretend that was the API. My point is the order actually matters, and you have to kind of replay them. And the problem is, what if this work happens on a server, like outside of your preview? You now have just an arbitrary new array that isn't what you expect it to be. Like you don't have these distinct operations anymore. And for that reason, every JavaScript framework does diffing on lists. Yes, Svelte, Solid, everybody diffs lists. Okay? And while there's people looking at ways to optimize like single operations, essentially there is a reconciler to diff lists. And again, there are 3 ways to diff lists. Magic number in 3s, okay? The 3 ways to diff lists are 1, by index, 2, by key, 3, by reference. Okay? Hopefully everyone's still with me. I know this is a very technical discussion and talk today, but I want to kind of pull all the elements together here so that we can talk about these things in the same sort of way. So by index is a very naive way of doing it. I mean, it's actually very simple, right? You just check what's in you just assume that what's ever in that index is the thing, right? You go, oh, okay, well, and the effect of that, sorry, I mean, I guess I should draw like a list, shouldn't I? Like we should draw like something that looks like a list. Yeah, let's do this. Let's make our list. Make our list. All right, cool. I'm going to need 3 of these ultimately, won't I? So let's make our lists. All right. All right. And so by index means, I mean, the thing that I'm not showing is I'm pretending like this is the final output, but there's like, this is so hard to show because there's like the previous and the next stage of it. But like if you switch the first 2 items when you do an by index change, essentially, so, I mean, let's play this game. Let's make more of these. It's fine. I'll just stash this away. Let's pretend. Yeah. You know what? I'm just gonna do this across. We're gonna go A. We're gonna go B. And let's put C in for good measure. Doesn't really matter. But what are you doing to me? Skeletor was like, no, your text shall go there. Okay. If we switch A and B, what's going to happen? And this is hard to show in this, but we're just going to take the same DOM nodes without moving them and essentially, all right, and essentially just override the DOM nodes. No DOM nodes actually move when we switch this data structure, because if you had a user here and it was John Smith, and this is, I don't know, Michael, I don't know, whatever, John Smith and Jane Doe, okay? John Smith and Jane Doe. When you switch it over here and you were displaying the names, you're just going to switch those names on the same like text nodes. You're not going to recreate any DOM elements. Yeah, I was thinking about using colors, but it's like this is so granular that it's hard to actually show the difference, because the text fields in here change. Maybe that's the best way to put it. Let's go here. Essentially, let's start with black and assume that we have a couple like text fields, right? Inside our representation. And let's see if I can make a couple more of these. Yeah, and this, yeah, okay. Thank you. Colors is how we're going to solve this problem. And then when we switch it, X is probably just going to be easier for me to just copy this one over. Well, this is by index, by the way. We'll do the other ones in a second. When you switch this by index, so this goes here and this goes here. Oh, actually, oh yeah, we should. Yeah, okay. Yeah, this is such a weird, coming up with the right visual for this is actually really hard. Yeah. Because what you're suggesting is that I should actually have made these as all separate blocks instead of making them as a one giant container, right? Like actually, like draw these as boxes. Okay. Thank you for helping me come up with the right way of representing this. Because if a DOM, we're going to color code each DOM node, okay? Which is a little bit of fun, but yeah, let's color code each DOM node. Let's make the next one green. And then let's make the last one some kind of blue color. Okay. I did not pick the same blue color. All right. Okay, here's our list. Oh. All right. Here we go. In business. And to be clear, I'm just gonna, I'll do them each one at a time. So we do by index first. When we switch these by index, what ends up happening is, funnily enough, even though the data changes and the DOM nodes update, nothing actually moves. So like, in all these cases, the DOM is fully updated to it looks like it's switched, but by index, you actually reuse the DOM nodes that's already there, right? It's basically like the props swap around. Someone was suggesting it's basically like that. Okay. In our next example, we'll do by key. And in by key, what ends up happening is actually a little bit easier just to delete this. And by key, what ends up happening is that, okay, let's copy all of this. They literally switch. A stays red. And green stays blue. This is what a keyed update is. And you might be like, oh, well, who cares? What like, sometimes this is actually a lot faster because you're not actually, like, if you're deleting a row, let's say you like delete C or delete A. I mean, it depends on the CSS, but like if you delete A in it, I mean, we can actually see what that looks like. Let's add one more example to our list. Let's delete B after we're done. So the operations are like initial, it, and then this is swap A, B, and then this is going to be delete B, okay? If we delete B by index, this is what happens. Right? If we delete B in keyed, we delete B. Okay, so this you might be like, okay, whatever, who cares? But I wanted to point this out because, my blog. This article has the best links to all the old ones. Actually, you know what? Maybe it's just easier to go to round 3 and then go next. No? Yeah, there it is. The reason we care about this, and this is the same reason that React yells at you furiously about not including click keys, is when it's keyed, it's the same thing. This is a really silly example, but what he did was he went in an element when it was non-keyed, he set the background color, and then he updated the data, and the element kept the color even though it's completely different data. And the example that, oh, did he update it? Oh, he did update it. This used to have a really cool example. No, here it is, with the CSS transition. See the X blowing up? You click the X, and it actually is still animating on the wrong element because the original, it reused the element. So like you deleted it, and then the other element shifted up, and it's still animating the deletion animation on the wrong element when it's non-keyed. So like essentially what I'm getting at is, it's not just this. Think about any place where there's ephemeral state stored in the DOM. Sometimes this applies to things like input elements. Sometimes this applies to things like web components, which tend to hold their own state. Basically, there's a whole bunch of things that it actually matters, you know, and you can get weird broken behaviors if you do non-keyed. And that's the reason why the JS framework basically ignores non-keyed. But the reason I'm focusing on this is it's the same reason that React yells at you to include keys. And this mechanism, as I said, is true in all frameworks. In Vue, they don't yell at you, or Svelte, they don't yell at you about including keys, but it is the exact same problem. Right? So I told you there was a third way to do it, right? Because the way to do it, when you do it by key, essentially what ends up happening is is on the element, you're like, you pick some part of the data. So you're like, oh, by keys. So like row.id. You're like, okay, if row ID dot matches, then we know it's the same thing. And then we can use those same elements again. But it's a little bit more sophisticated than this, because what if you have multiple changes happening at the same time? What if you both swap the row and add more, like update it at the same time? So the thing is, if you swap a row, if you have immutable data, swapping a row keeps, like, the reason you need the key is swapping the row keeps the reference, right? If you ever, I mean, like what, like the typical pattern for immutable data. Let me see if I can. Do I have another playground open? Yeah, okay. Like typically, if you were to swap a row with immutable data, what you do is you start with array 1, right, and then which has some stuff in it like A and B, and C. And if you're going to do an immutable swap of these, what you might do is go, const array 2 equals, like, there's different ways to do it, but you'd make a clone, and then you'd go, okay, well, array, I think I can even do, I can't remember if this works. There's like a cool trick you can do with ES where you can do like, I'm not gonna be fancy. I'm just gonna do it. Okay, so we're gonna say that array 2 at index 0 equals array 1 at index 1, and array 2 at index 1 equals array 1 at index 0. And if I console log array 1 and array 2 at this point, we're going to see a list that has been swapped and unswapped. So the original is unchanged, the change is immutable. But these are simple values. But now if we have an object and we're doing this, right? Yeah, our console is kind of compressed these all out so we can't see them as easily. The challenge here is this is fine because we didn't change any of these objects and the references are going to be the same. But if we actually, on top of swapping them, also want to mutate the value here to, let's say, A1, what we actually have to do is clone it as well. We need to take, so we need to go this dot array 0, and then we need to go v equals A1. And I'm cloning it. To be fair, I don't need to clone it because it only has a single property, but I just like, this is the typical immutable pattern. And in so, because if we didn't clone it, I mean, I could show you what happens if we don't clone it, but the original array at index 0 would be changed, but we can see in the original array here, it's A, and in the original array, and in the new one, it's A1. See, B is fine, B is C. If we didn't clone it here, and we just changed it, we would basically have corrupted the original data and it wouldn't be immutable. But my point now is these are different objects, right? This object now that's sitting here is not the same as the original object that was sitting here, which means that it no longer, it basically, you need a way of knowing it's the same. And that's why we have the keys, right? In index, we didn't care, but we have the keys here because if you key by just the value and you clone this immutable data, well, it's going to think it's a new object. It's going to destroy and recreate it. So we need keys to know it's the same thing. And more so, when we hit something that matches, and it's the same with all of these ones, essentially, if it matches for both of these approaches, we actually what I call merge deep. By that I mean or diff deep, because we need to know what changed. It's not enough to know that the object has swapped. We actually need to know if any keys on it had. So when we match here, we're like, oh, match. We go, oh, it's not not equal. Like it's a different object, match, and it is a different object. Man, I'm getting cut off on the side here. I don't know what's my best way of doing this, but yeah, if it matches and it's a different object, match plus diff object, diff different object, diff deeper. Okay, so in both of these approaches, like essentially once it's placed it, if it knows that like that something has changed because it's a different object, it needs to actually diff deeper to make sure that it doesn't miss any changes further down. And I want to show you the third approach now, although this one will be a little bit quicker to do, because the third approach is almost identical to the keyed approach, okay? And this is by reference. But by reference doesn't really work with immutable data, because key is actually an improvement on that. If you do by reference and the object changes, it's not the same reference. So in a sense, this is kind of awkward because you don't want the change to be immutable. You don't want to do this. By reference means all your change has to be mutable. Okay? So the key part for this one here is mutable. That's the key part. So if we're like kind of trying to cover this whole zone here, these ones work pretty well with immutable data. This one works with only mutable data. But you don't need a key, as long as you can keep the reference. As it turns out, reactivity is mutable. But it has an interesting characteristic, because when you match in this mutable world, when you match and you realize that it's a match, because it's the same reference, it can't possibly be different, deeper. Like you can't tell. There's no way for you to diff it. So when you match on a reference thing, you match and stop. No more diffing. Match and stop. If you want something deeper to update, like one of these little cells here, you need to update it independently. No. Svelte uses the first two. In fact, almost everybody uses the first two. All the popular frameworks. Like up here, this zone up here is React, Vue, Svelte. I don't know. Angular probably has the means to do this in one of their billion modes, right? But this is how you do it in all these frameworks. Is the last approach the fastest? Of course. I mean, of course it's the fastest, right? But there's a trade-off, because the object can't change. So if you want something like this, is like, it's not just solid down here. knockout. I think old Angular, like Angular 1, like basically frameworks that were based on this model of the create once, right? I told you Svelte is more like React than it is like Solid. Right, but reuse rows is non-keyed, which is dangerous, right? Potentially. So we're talking about on the keyed side of things, right? I think there's ways to mitigate that potentially, but just on a pure reusing rows is some kind of hybrid between like the by index and thing. Like I think you could do some clever stuff where you could like hold something and kind of purify it, and you could get some improvements by not recreating the DOM, and you could probably keep it clean enough. But like generally speaking, reuse any kind of DOM recycling. Like there's ways to optimize things even further, because by index often is more performant. So if you're selective, you could be like, I want certain operations to work like indexed and then other ones by ref, and then you could like make the most optimal solution if you knew what you're doing. But as a general solution, it's dangerous, is the way I'd put it, right? Right. So the thing is, this works really well for Solid because it never wants to recreate anything anyways. Like, why would we bother? And because we never create, we have these fixed things, right? Like, like, we already kind of went through this. Like, if we create things once and it never reruns. But the thing is, you have to understand this always has to diff deeper if it detects a match. And generally, because of this, no, these systems don't care if your data is deeply nested. Generally speaking, like if you update a list, you can just throw it in a signal and it'll just diff downwards, right? Because it's like any change of data, like our to-do app or like our JS framework benchmark, you know, any change, sorry, not that one, any change here, like if I'm updating every 10th row, it's actually running through the list reconciler and actually going, oh, these ones changed. So I'm actually going to check that every 10th row changed. So I'm matching. Yes, these are the same. Sorry, matching, not the same object. I'm going to diff, see that this changed, apply it. Oh, it's funny, I clicked on it. Then go here. Okay, same element, no change. When I swap, it's going to go, essentially, it's going to go, okay, same, fine. Oh, different element, find it and go, okay, but I found it, so I know that it hasn't changed, so I don't need to diff it, right? Well, it depends. Like if it's key, if the key matches and the reference is the same, then I know I don't have to diff it, essentially. But essentially, all changes to the array go through the top-down array reconciler with most frameworks. So like it's, whereas if you are doing this referential thing and you're never doing that, like in the case of Solid, when you click update every 10th row, it doesn't run the array logic. It wasn't the array that was changed. It was a signal that you created once down in the tree. So it doesn't, this has nothing, this doesn't even know that it's in an array. It's just updating independently. It's just like that one text node. Right? So like, this is interesting because, to be fair, if your system only has by ref, and this is Solid's 4 component, to be fair, clear. We also have by index, but this is Solid's 4 component completely. How do you handle data from the server, or like the stupid DBMon benchmark where you're like shooting people fresh snapshots that don't have data? Like this works really good for fine grained stuff. Like when you go, okay, I move this row or I sort this list. As long as you have the change and it's happening in the DOM, it's fine. But if it's coming from a server, it's like, okay, this is all new data. I can't match it. How do you match it without a key? Well, the solution I came to with Solid is actually handle the data at the diffing level. And we have a reconcile function for stores where we can do data diffing and then promote out the fine grained thing. But the reason I did that way was because the DOM now is really stupid because there's a diff mechanism, but it's just for this. But it's like one of the simplest diff mechanisms in that sense, because we don't do deep diffs. If you just go use Solid right now, by default, there's no deep diffs. We don't ship that code with the main part of the bundle or whatever. Like it's something you opt into. So again, this isn't all about solid, but I just wanted to kind of point out that this is one of the reasons why, and I've mentioned this previously with the JS framework benchmark. Classically, VDOM libraries have had a very difficult time with these, not super difficult, but they've had a harder time with these two rows, because selecting a row and partial updating a row are going to have some overhead, right? If you get to this side with the reactive libraries, you'll see it's like almost partial updates are like pinpoints, so they almost have no overhead over over the vanilla DOM. But yeah, over time frameworks have gotten more have gotten more optimal in these areas. But historically speaking, this was basically adding reactivity made these fine grained updates like partial update and select row faster. That's what they did. But they don't affect, like they if anything, they probably, if you're building a bunch of reactivity, they kind of have a cost on the other end. Right? So it's challenging, right? I wanted to just point this out here because the difference by mapping by ref and mapping by key is actually different. Even though they look the same, by key ends up doing more work potentially. It's possible though, because as long as you do mutable change instead of immutable change, it does cross the boundary pretty well, right? Because, but you have to make that decision when you do the update. Because if you do mutable change, then this doesn't know that it's changed and it won't rerun the list, and then that deep mutable change could run independently. And again, just doing this to kind of get the context. I think I've explained arrays and lists well enough now that we have almost all the context we need to get into most of our topic today. Yeah, and you're getting there. So then you're like, okay, clearly there's a trade-off between reactivity and VDOM. So what if we use them both together? Wouldn't that be the best combination possible, right? That's where all of this is kind of heading to. And luckily for us, there's a framework that's been doing this for like 7 years, and that's called Vue. Very long time mixing, kind of matching these patterns together. And essentially, Vue does fall on this side of things, but Vue has done a lot of really smart stuff, because I mentioned before, there's this really awkward thing that with a reactive system, you want less components, and then with the VDOM, you want more components. And it's like this really awkward tension. And Vue used to get hammered here, like in benchmarks. Let's see if I can find some historicals here to show you what I'm talking about. Let's go back. Can we go to like round 7, I want to say? Maybe round 8. I can't remember. These are classic benchmarks. Let's see if I can find this. See, like select row or something. No. I think this is partial update. Yeah, okay. How about partial update? Yeah, partial update. Do. Vue is over here. 168 on partial update. Okay. Over here, we look knockout. This framework is like super freaking slow. Like, from our modern standpoint, huge hog. But it's like it's like right up here with the partial updates. Felt's actually pretty fast here. Surplus, Angular, Surplus is kind of like Solid's predecessor. This is before I put Solid in here. Reactive. There's a VDOM library, Eevee, in here. So props there. But my point is, look, React is here. It's not even with MobX, React and MobX, React Redux, React. They're kind of in the middle of the crowd around 93. And then you have Vue over here, way over here. Just putting reactivity and a VDOM together is actually kind of terrible for performance because you're taking both costs. Suddenly you're like creating this VDOM and you're creating the reactivity. Like sure, the reactivity should. The funniest thing about this is, I was like, this one was weird for me because I was like, wouldn't the updates be fast because the reactivity? And like it depends on which one you favor. The problem is when you build the implementation, they had to make a choice: make all the benchmarks slower or make the one slower. And they decided to make the one slower because it was like a better trade-off on performance. But it was like, do you make more components and optimize more the VDOM way and get better creation, or do you make less components and take the hit the other way, where it just is a very difficult balance that happened. And it was like that for years, honestly. Vue managed to always get in front of React in terms of performance, but only marginally, because they spent more time on performance and tuning it. Like Vue did a good job of tuning it and making it better, but they had a much bigger hurdle to overcome initially. But then they found a solution. I love this solution. Vue 3.2. So only about a year or so ago, quintessential what is it called? Quintessential quintuplets. Okay. They made their reactive implementation like way faster, which is good on them, and improved memory usage. But the big thing they did was they added this vmemo directive, because now they had the ability to essentially make the large components that the reactive system liked, and then say that, like, actually VDOM, treat this almost like its own component so that it can optimize run separately. And by annotating parts of the template, you can now get the benefit of having like multiple components in a reactive or in like a VDOM system with keeping the boundaries large that reactive system things. And yeah, it was a big push. Vue went from being like in the 170s or 160s, or I think around that point, so like they basically just jumped right past Preact and straight into like Svelte territory on performance, because of being able to actually have a solution to optimize it. But as I said, a naive approach here doesn't help us, because it, like, you're just taking both overheads. All right, everybody still with me today? It's really hot in here. Okay, so yeah, I wanted to talk about that because Vue's approach is like an amazing piece of engineering, because they figured out how to take the VDOM, find the static nodes, hoist them, do a whole bunch of optimizations to actually let both sides play nicely together, like the vmemo and all this stuff. But naturally, just mashing both systems together, actually, while it's like really cool for DX, is actually really bad for performance. Yeah, I do have AC, but we have to be careful running it, essentially, because we've been having rolling power outages if people run the AC too hot. So I'm pretty sure we're sitting at about, not too bad, like 82, 84-ish, but the lights in here make it kind of difficult. You guys are hilarious. I thought Vue had 15 modes. No, I think Vue has like 6 so far, but there'll probably be more. Okay, so yes, here we go. I've been going on about this for long enough that we probably should talk a bit about. Let me make a banner. I've been so bad this stream. We should probably talk about Preact Signals, because I've already been talking for 2.5 hours and I haven't even talked about it, which I warned everyone at the beginning, because that's what I'm doing. No, not 80 degrees Celsius. No, 80 degrees Fahrenheit. Yeah. So this is an interesting thing because, oh, I guess there's one more piece before we really get into it. Sorry, guys, I put this banner up prematurely. I'll bring it back in a minute. Okay, one more thing I want to get into because this comes in. I showed you about, we talked about Vue, but there's one other place where we mash reactivity and VDOM together, and that's state libraries. It started with MobX, and yeah, actually, you know what? Let's make a banner. State libraries. Yeah, so I want to talk about state libraries, right? I kind of talked all about change management to this point, but what ended up happening, and this is going kind of back in time here, because there's a side effect of this move, right? Because at this point, this was very much a concern. We had this change management mechanism, and I'm going back, a little bit in the stream to kind of come back here. We went deep, but we're kind of stepping back for a minute. This was because this was all part of the framework. It had to ship with the framework, and this is the only way things happened. So essentially, our framework would basically create the whole system for us. And before React's component model came out, you would just use the mechanism the framework shipped. You're like, oh, that's how change works. There was no idea of state management libraries because models were kind of implied. Even though a library like Knockout didn't have models, essentially, for the most part, this architecture was implied. So even though the library might only ship with this part, some of them did ship with the models as well. Essentially, you knew that you're in the neighborhood for models. You get some backbone models or whatever. This is what you were looking for. So essentially, there was never a question of how you'd handle global state or like state management because it was part of the framework. When this happened, like React was kind of like, we don't even care what's over here initially. They're like honestly, this is just not our concern, right? And to be, as I said, other libraries like Knockout had taken sort of that stance, but now because we had these kind of pockets, like you could live in this whole world and like pretend this didn't exist anymore. And so React was like, yeah, whatever you want. But we had a lot of people who were like used to this kind of stuff. They're like, well, I got database models. How do I keep it in sync? How do I manage this stuff? And React kind of gave us an answer really early on because they realized that people were confused because they're like, everyone's like, doesn't the framework handle this? And React's like, no, we're a library, right? Like this is where I feel like the framework library distinction came from, right? Because it was like people expected this kind of consideration to be part of the framework, and React's like, oh, we're just a Vue library. We just do this part. Obviously, I called React a framework in my last stream, and people gave me heat for it, which I find a little bit amusing. It's hard not to call React a framework these days, but I mean, early on, I think it was the library statement was fair, and it made this distinction very clear. That was its goal, and essentially, they didn't care. So they showed us Flux, which could actually be implied on a lot of models, like things like Backbone worked with it. And they also, not before long, Redux came around. Right? And Redux is a beautiful, simple thing. It's so funny because when people talk about Redux and they're like, oh, it's so complicated and all that. What's complicated about Redux is it has so much boilerplate because it is the simplest solution you could think of. And I know it's so weird because it's like not easy, but it is incredibly simple. When people talk about a difference between being simple and easy, Redux is an example of like at its core, it is the simplest concept, but it is not easy to use classically. There's now Redux toolkit, which makes it easier to use as well. But it's because the simpleness of the model was just like I mean, it's an equation, right? Like it's almost like React's own equation. Like how far is Redux from React when you consider the equation, right? Because React's equation was, what was React's equation? Everyone loves the React equation. What is it? View equals function of state, right? This is React's equation, right? We've all seen this. Redux equation is state is a function of state and action, right? It's boilerplate hell traditionally when you don't use Redux Toolkit, which makes things much easier to use. But it's because it's this simple. Like, you don't need a library. Like, if you want to use Redux philosophy, you can literally just go like write a function somewhere. Like, you don't need Redux to do Redux. Like, it's just a reducer. It's just like, I mean, React added use reducer inside the core when they went to hooks. Like, it's just like, it doesn't take long to see how these chain together, right? Right? Like, if function of state is view and state is a function of state and actions, and we use mathematical composition here, then there go, view equals a function of state and action. Look, I've solved the React equation. Right? Like, but what I'm yeah. So like what I'm getting at here is that like this fit really well with their model because it's like you don't do any work until you ask the question, which is function. It's pull based, but people wanted push based solutions. Obviously, like they wanted to be able to like this was really automatic, especially with like two-way binding. Like this circle becomes two-way binding basically, and they're just like, what is all this boilerplate to set all this stuff up? So people came up with an approach for that. One of those approaches was MobX, where you basically all you have to do here is keep your component box, right? Sorry, let's drag over here. What if you could do this? Sorry, I gotta get the right selection. There we go. What if we could take this component box and let's get over here a bit. And what if we could kind of do like play a little game here where we stretch this out a little bit and then we're like, okay, I got a secret for you guys. We'll move this up here. We'll put this over here. We'll keep it inside the box. And then what we'll do is we'll make another little box in here. Or, you know, maybe we won't actually keep it in the box, actually. We'll make it look like a box is a better way. Let's actually leave this box here. And then we'll make a pseudo box. We'll make it maybe a nice purple color, ... We'll make a pseudo box here and we'll do this. And then, all right. We'll be like, this is our component. Sorry. And we'll put, I'm going to just put the label MobX here. Okay. Okay. And we'll make this our component and we'll do a little secret where this part runs once and it's hoisted out. And this part runs lots. This is basically how Vue works too, in a sense. But the trick to do this with inside React was hawks, essentially. You can make this run lots using wrapping this in an effect, essentially. We could just like, we can make this an effect to run the JSX view and then memoize. So the effect is here at this boundary and then memoize this boundary on props, memoize. And essentially, so this is like, when I say memoize, I mean like React memo, like essentially. We could basically separate the component, make it look like a component, but give it isolated areas to execute. So in here, MobX might be like, oh yes, let's create a observable, which is the same as a signal and all that stuff, right? So observable here, and then down here we're like, there's an effect. Let's, you know, listen to. I mean, you just read the observable here. I don't know what the best way to say that, but like this here is like create create observable up here. I'm running out of colors. Sure. And then down here, we're like read observable. And now we have our auto tracking for our reactive system, and we can basically live inside a React world. But the problem is React doesn't know about this. So you basically have to write a whole bunch of wrapper hawks to basically split things apart again and let you get like component level semi fine grained ish updates in your system. Right? So this is this is really kind of convoluted, but the wonderful thing about it is you just start authoring components that feel like they run once. You build some state and then you read it in the JSX and like you're done. This is how Vue works too, essentially. Like Vue internalizes it, which is why it can optimize it. In React MobX, you actually have to like write a whole bunch of wrappers. So essentially a little bit messy trying to make it work within React's constructs, but it actually works really well. And the truth of the matter is there are other mechanisms kind of similar to MobX that do this sort of game, right? Where, we've talked, or people talked in other things that like of this school here, you have things like Zustand or whatever, right? Which is kind of continuing off this side, perhaps, or the Redux side or whatever. But then you have on this side, there's things like what, the Valtio, I know, or Vialto, I don't know the name of it. Sorry. But like a lot of the state managements, there's like with hooks, there's like a third version, which is kind of in the middle, which is where like Jotai lives, which is where it uses something that looks kind of like reactivity, but actually triggers the internal stuff inside React. But essentially, there's the three types of state libraries in React that kind of follow along this side. And this is a newer post-hook things. Recoil's in this pile too. Actually, let's just give ourselves a little bit more space here so I can talk about this more. It's like end of the mouse pad. All right, let's go up somewhere here. Okay, cool. But my point is, they all have kind of different takes, right? This side is very much like on this kind of trip of like, kind of, how should I express it? It's like everything is pull based. It's like pull derived. Like it's kind of like, and this side is very much on this kind of like push kind of reactive kind of thing. To be fair, most of these systems are actually push pull, but I don't know how much I should strain on that. And then this type is this kind of it's smack in the middle. I don't know what to call it, but right. The truth of the matter is these libraries have gotten more popular because these use like this is like, in a sense, this is like this use like, I'm trying to think of how to differentiate this side, but like this side uses plain objects, generally plain objects, right? This side uses reactive data, and this side uses React's own state. This is probably the difference, if I may, between these approaches, is that like this doesn't care about the data being in the data, like doesn't care about the change being in the data. it's like completely pull. This one, all the changes in the data, and this one's using React's own mechanism, right? And the thing is, using there's a lot of benefits of using React's own mechanism, because when you add another piece on top, like another state management mechanism on top, you have this challenge of like React's change mechanism still has to run under the hood anyways. Now you just have two systems. This one eliminates it, and this one isn't really much a system in itself. This is very much aligned with what React is, where this one actually like uses React, and this one is like its own thing. And the reason I wanted to point this out is I haven't looked at the recent results recently, but I want to show you something. It's that a bunch of people come in and they're like, "Oh, I'll create this state library and I'll improve React's performance." And I mean, let's look at state libraries' impact on performance. Okay, so the slowest one I see here is called React Starbeam. This one is that new universal reactivity coming from the Ember team. I think it's still like in beta or whatever, which is probably why it's way over here. But then we got React Focal, React Diagon, I don't know what that is, React Zustand, React Redux, they're both over here. A more optimized Redux, the traditional React Redux, I guess this is the hooks version. Let's keep on going. React Tag State, React MobX, so here we're getting some of those reactive libraries. React 17, this is the class implementation. I don't think it's very optimal. React Recoil, React Easy State, and then we get to React Hooks, okay? And actually, you know what? Screw this. I think I have an easier way of showing this. Let's just go which frameworks and just do none, and then just select all the ones that are prefixed by React, so we can just like see them all in one easy thing, because we have a lot of React state libraries in here. And I don't really want to focus on everything else, but I want to show something here. If you look at this graph, oh, Jotai wasn't prefixed. Good call. Which frameworks? Jotai. Elemento. Yeah, so I might be missing a few. Thank you for pointing that out. Jotai. Elemento. They changed the order now, so that's in a logical order, but I don't always see it. And is val to also not prefixed? Okay. I think the other ones are. Okay. Yeah, I got them both. Okay, so Valtio's here. Jotai is probably up a little higher. Where did it end up? Yeah, Jotai. Look where Jotai is. Jotai is actually, apparently, according to this benchmark, the fastest state library. And I'm not surprised, because it literally uses React under the hood. This suggests to me, though, that either this is a very bad run, because, this suggests to me that this is a weirdly bad run, because most of the React library, there's something weird on this run. That's unfortunate. Okay, my point is, if you look, other than this Jotai spike here, and as I said, I think something's weird going on here, all the React libraries and state libraries are essentially in this zone. You don't suddenly make React way faster, is what my point is. Jotai seems to be like breaking the rules right now, but I've looked at this over years. You can't change. There's this React lab at the front that is like green, and that's because it's like an experimental that's not real React. They're trying like other things, but you can't change what React does very much. Looks like there's a way to optimize select row that the hooks implementation, like the idiomatic's not doing it. But if you can do it in a state library, you can do it in vanilla React, is what I'm getting at. React is always going to be faster than any state library you add to React. If there's like some variation here of like 0.01 or whatever, it just means that those libraries did a good job of having low overhead, and like they're basically on par, and there's just some variance. It's in the same way that like no library is faster than vanilla. like solid on one benchmark, I think came out faster than vanilla, and that was kind of like fun, but it wasn't real. You don't get to improve React's performance by adding a state library. Okay? And the reason that something like Jotai is going to be more performant than the others is because it's not adding a new thing. It's actually literally using React state. Like, if you use the change management of the framework, it's always going to be faster than introducing another state library. This is a fact. This is non-negotiable. You can make different trade-offs that might average you out better in certain ways, but you cannot intimately improve React's performance. Right? You can't just go like, oh, I added reactivity, now it's going to be faster. No, that's not how this works. Usually what ends up happening is you take hits in other places. But yeah, I usually you'll see it here. Like the reactive libraries will actually have slightly higher creation overhead and append to rows. Like I'm looking at MobX. These are higher than vanilla React. So are Valtios. Whereas something like Jotai is almost identical to React on creation because it is just using React's own mechanisms. This is an important point because people seem to think that state libraries can improve React's performance. They cannot. Like, they literally cannot. Okay. What about the Millions project? Well, I don't know. It's not if they could make a different implementation of VDOM and be React compat and be faster. Like I didn't throw it in here, but you guys like Preact for like a benchmark like this, React has some different features than Preact, like they have kind of split off of it, but like Preact, bam, it's ahead of all of these, right? React compat for the purposes of this benchmark, and it's interesting. Preact actually has some hits here. Their select row is actually, although I guess React hooks is actually no, Preact's right online. But look, Preact has a smarter reconciler. You can see that it swaps rows better. Where like for lists, where React has a really naive one. That's why all of these are red. Like the state management can't fix the performance of the underlying reconciler. Yes, state management makes it easier to improve your code quality. It doesn't make React faster. Yeah, the VOD will be available both places. So, yeah, I just want to like point this out. It's not like you couldn't have a faster React. Another framework that has React style compat is Inferno, and as soon as I add Inferno in here, stuff starts really shifting down, right? So it's not a matter of React's API. There is an implementation thing. Inferno and Preact both don't do things that React does, so it's not like a fair comparison. But I want to point out that taking a library, adding a state library to it, will not improve its performance, right? The funny thing, someone's mentioning me with context. God, that would be painful. It was in here for a while. React Redux, when Context API was released, with Redux 6, made the mistake of moving Redux to using the Context API, and it just tanked on performance because the context, they were using it in a way that they were updating React's own state and causing re-renders, and it was terrible. They actually had to rush out Redux 7.0 to actually fix this problem because they tried to use context. If you use context naively, but using just like context and causing state re-renders using like thing, it is not good. Yeah, exactly. These current results are bugging me because these remove rows, Preact has it too, are bugged. There's a problem with this run. Maybe we shouldn't even look at this run, but it bugs me. Sorry. Let's go official results. Let's go 104. 104 was better. Although I lost all my nice filtering, unfortunately. I don't know if I want to go through all that again. But yes, let's do it. Because I consider the 105 results kind of glitched. And it's really unfortunate because, as we all know, okay, and Jotai. This gives us the second point of data too. We can see, and we had Preact in there too, and Inferno. We can see if Jotai actually has repeat results here. Yeah, yeah. So here we go. Jotai is legit, even on this version. They have actually. It makes me want to review the React implementation because if Jotai can be faster, React can be faster. That's just the science of it. So where am I? Where am I looking for? Inferno. Inferno. Yeah, there we go. Much better. And actually, I guess Preact actually that was accurate. But as I said, so you were right. It was just Inferno with the glitchy results. As I said, performance isn't inherent for a benchmark like this, VDOM versus non-VDOM. I would say, like a state library, sometimes it lets you write more performant and better code, and that's why you might want to consider reactivity, but it's not generally for performance. Right? So yeah, Inferno is, someone asked, forgot for Inferno, yeah, I did, but it's back now. So this is a key distinction because, like, just to kind of put it out there, without any fancy state library tricks, if you put Inferno on this table, you can see as a VDOM, it's not just faster at select rows and swap rows than, say, all of these, but it's faster at creation, partial updates. It's literally faster at everything. Like, this is going to be a very red table. Yeah. If I compare it. Right? So this kind of helps us set expectations on what we can do when we mix basically a state library on top of a VDOM library, right? Unless there's a change to the core of the VDOM library, and let's see, can I get view in here too? There's only certain places where reactivity actually really helps on performance. And those places are going to be partial updates and select rows, generally speaking. And the reason for that is not reconciling the whole list. So this is I wanted to kind of look at this here because I think this is basically, yeah, I wonder which framework they coded this cool data table with. Any guesses? I'll tell you right now if you haven't looked. This table was built with React. I mean, there's no denying React's influence, right? I'm almost positive it's, yeah, this table's coded with React. I mean, we could probably look, but I'm very, yeah, well, yeah. I mean, I forget how we did on this one. We did pretty good on this one, I think. Yes. 1.4, yeah. And Inferno, here, I mean, here's my point earlier. The difference between fast reactivity, fast VDOM is not always that big. They used to test this on a computer where solids gain was a lot larger, but they've changed the testing setup, and now these results are actually much, much closer, which is probably a good thing. Makes my point easier, but okay, so Yeah. Now I have finally given all the context. So let's talk Preact Signals. Okay. Thank you all for bearing with me. It took me 3 hours to get to the point where I felt I could talk about this topic. Okay. So let's get real here. So I have to admit, where was it? When I first saw Jason teasing some stuff, and if I look far enough in my bookmarks, I'll probably find it. I just don't know where. Not Twitter Blue. I want bookmarks. Yeah. If I go back far enough in my bookmarks or on my stream, I'll probably find where he first started teasing it. Yeah, here we go. No, that's Million.js. Someone asked me about Million.js. I already talked about this previously. They had some cool ideas. They're still trying to get their implementation of the JS benchmark down. This is why it's really dangerous to be like, oh yeah, 10 times, 11 times faster than React, right? If you go in here, you'll see that this has been open for over a month now, and they're still kind of working through what it's going to take, right? Because someone ran the test of the draft version. They're like, what's going on here? Millions is much slower than React. Why? What's going on? And yeah, I mean, this is not the final PR. They're still working on it. I think that it's always possible to find a single thing to measure. I do like this benchmark. It's not perfect. It doesn't measure everything because it has so many different things that it tests. But this is not the end all be all. They did have an example where they were doing less work. But I think, I mean, yeah, maybe I just have to go through my feed. This is called me not being prepared and basically last minute deciding I was just going to do a stream today off the seat of my pants, so to speak. I should do more preparation for these things, I feel like, but what can I do? Sorry, not what I wanted. I wanted my profile. Yeah. If I scroll down far enough, you will see, I mean, I don't want to go all the way back, but you'll see they've been hinting this for quite a long time. And Jason showed this really great graphic where he'd shown like a React graph and like a previous graph and a reactive graph, and you're just like, where's all the code gone? And it comes down to understanding what they've done with this. So first question people ask, Preact signals, are they like solid signals? Definitely. Or Vue. This is a shallow ref in Vue terms. This is a signal in solid terms. Yeah, I mean, I could try scrolling Jason's profile. I want to feel like he's more active than that. But, oh, come on. I've been having some trouble with Twitter today. But maybe if I scroll here, I'll see it. Because you got to figure they did the announcement, so like he's gonna have like a whole bunch of stuff. Yeah, I just love all the hinting. No, they're just like it's coming. Where was it? Yeah, here we go. Yeah, this is the one. Thanks for suggesting that, Fabio. This, and you're just like, wow, what is going on here? Well, I'm gathering this is some kind of animation test, right? Because that's where fine-grained reactivity just kills it, because like you're updating one text node and you're doing it. But as I've mentioned before, naively just smashing the two together isn't going to get you what you want. So I think we gotta actually look at the solution here and talk about it a little bit, because let's get right into it. They did an introduction here, and the cool thing that I saw right away is I think this is really cute. They showed how it's outside of the component first as the shots fired. It's funny, I didn't even realize how big of a deal this was. Like I started doing this in my solid demos and stuff and to showcase it, but like to me this was just like obvious, but for like this is like the shots fired, right? And yeah, state here. It's talking about, the problem of only co-located data, right? So binary state, blah, 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 blah. Okay, and then yes, here's the image again. That makes sense. bringing signals to Preact. Yeah. So yeah, this is showing. Let me see here. We've done the very primitive. Where the ergonomic advantage compared to third-party things that rely on selectors. Yeah, a lot of things require you to wrap it in a hook. Selectors are really useful in what I call pull-based reactivity. Right. And then essentially, okay, so we have, see, there's no wrapper here. If you've ever used MobX, there's usually like a wrapper to use the value. You need to be like observer, like a hawk, like I showed you in that image. Like there's a reason why this is so ugly. In new version of Preact, you don't actually have to worry about this isn't happening to you. Like if there's any element of that, it's happening under the hood. Where is it? There it is. So that's cool. So at a base level, what we have here is basically a state library that doesn't require any ergonomics, additional ergonomics. And if you have global state, you're not actually taking much of a hit from the reactive system, because it just gets created once on the outside, and then you just read the values as you need to. And you know, if these wrappers are not expensive, that's the question, how expensive the wrappers are, then you're fine, because when you read count.value, you make counter subscribe to it essentially. And when you update it, the whole component reruns like the way it always does in React or Preact or whatever. And you're good, right? Like you just added some reactive state on top of Preact. So like this alone, thinking about this as a solution, I immediately go, okay, so this is very much like adding MobX, like a first party MobX to Preact essentially. So like that's the level one thinking here. So from that perspective, I can be like, if this is super optimized, what this will have very little overhead. It'll just essentially give us the ability to now like let the state management make it easier to write good apps, because it's easier to manage state this way. And while technically it's another system on top, it's kind of like what we were seeing earlier with React. It might be a slight overhead over Preact. So like I imagine you can use Preact as normal, and then I have the full table here, so this is no fun anymore. But or actually this is the one right here. Like it might just be very minimal, because like if I look at something like MobX over React hooks, there's like a couple point hit on creation. I guess the creation part was probably the biggest hit. So when there's mass creation, but for the most part, it didn't really change much. It just made life a lot easier to use. So that's where I like my mind sort of comes in. There's basically a minor cost for a huge ergonomic improvement, because now you're not worrying about dependency arrays and whatnot. And I have to admit, back in the day when I used React, I used it with MobX very, very often. So like this is pre-hooks was like, this was the React that I was used to, so to speak. So I think it's really cool to have this built in. So, but the problem, as I mentioned already, is this fundamentally doesn't change the performance characteristic of Preact. I don't think I'm wrong in saying that. It doesn't take any kind of, if anything, this should actually make the performance slightly worse. Maybe it's minor, but in theory, this should not actually make any sort of improvement. It's just an ergonomic thing. But then they have this cool thing, and this is what I want to talk about. Can we go even faster? They're like, we could have stopped here. We needed to see how far we could push the Preact integration. What we've got going on here is they're like, well, what if you don't read the value and you just pass the signal straight through? And this is a very clever trick. I've never seen anyone do this. What they're suggesting is if the VDOM, I told you the VDOM, remember if we go back to our silly example here, we're just creating this VDOM. If the VDOM comes across and goes like, and you assign something to this VDOM thing right here that we create, like this is a really bad example, but if we add an observable or computed or something to the VDOM, essentially, so instead of passing the value, because count.value, like the way the signal work, I haven't really talked about this much. I kind of glazed over because most of this audience is probably familiar, but essentially, if the count itself is the signal, and then if you go dot value, you get the value of that signal. So in that case, count dot value is 0, and you can then like basically assign a new value to it, like using equal sign, and then that's how you set the value. But that alone is not reactive. That's just the value. It's the accessing of it. When you go count.value, they use a getter, but it's like my proxy example. That's the point at which they track that it's a subscription. But if you pass it, but they're not doing auto tracking. If they're tracking a subscription here, it's literally on the whole component because you're accessing it in a place that gets re-rendered over and over again. But they were like, well, what happens if we just pass the signal straight to the VDOM? Well, then the VDOM can go, oh, I have a signal here, and it can actually do something kind of special. Because you might be like, well, how do you mix a VDOM with a reactivity? And I told you about all this recreation stuff. It's really, really quite awkward. Well, what you can do is when you get a VDOM with a signal in it, go, because you didn't access the value like this, at that point, the component isn't subscribed to the change. And you have the ability to control it. So what my understanding, I mean, this is a drastic oversimplification, is that Preact, when it gets an observable in the VDOM, just makes a pseudo component. They just make a little component inside that component so that that little component can be the only thing that updates, essentially, instead of the whole tree. And because they might try writing directly to the DOM. I'm not clear about this, but generally because you want the representation to stay in the VDOM, my suspicion is, and we probably want to dig deeper, is they essentially just make another more granular kind of component-like construct inside that now knows that whenever this count changes, update the text. And this can still be batched and queued with the rest of the VDOM stuff, I assume. So it's probably still like a semi-VDOM layer, but it's like picking the smallest component to re-render instead of re-rendering the whole tree. That is essentially the mechanism here. And let's see what comments are coming in right now. Yes, yeah. I actually saw I did benchmark it. I actually saw the speed up in the Kraus benchmark when I benchmarked it. The problem was I actually hit a memory leak, so I don't want to publish the results and talk about it because it overemphasizes the thing that I've been trying to emphasize the trade-off is. But one thing I can say with 100% certainty was when I ran the JS framework benchmark for Preact. We'll look at it in a minute, but not the benchmark, but the implementation. When I ran it with Preact, I got these numbers here down to Inferno levels. Partial went down from 118 down to about 93. Select row went from 30 down to it got down to almost view levels. It got to 20.2 or something. So essentially, both these numbers shot way down. What I witnessed was all the other numbers went up, but I think I think that is largely because of the memory leak, the degree they went up. I think in general, it's what I said. A state library added to a VDOM is going to have a cost that taxes everything, but this little trick that we see here actually improves the partial updates like in a significant way. I think the challenge here for people with this benchmark specifically in terms of expectations is that is that reactivity isn't going to generally improve these other stats. So even if it was zero cost, it's not going to impact the majority of the things. So from a Krauss benchmark standpoint, this is probably good for about 5%, which in the rankings doesn't really move it Preact much past Vue or Svelte or whatever. It's still kind of just bumped up. So it's a good gain to have. But what I'm more interested in, and I can't tell until we fix the memory leak, is how much of an overhead it is on the rest of this. Because I think that's going to be the part of the deciding thing. Because I actually implemented benchmark in 4 different ways. And I actually want to show that in a minute. But I'm not quite there yet. It's actually really quite cool when you start thinking along this. Right, so Preact now surgically updates the VDOM. Yes, basically, if you pass a signal through or compute it, it knows to surgically update it, which is really quite cool. Can I add HyperApp? Sure. Where's HyperApp? HyperApp it's been a while since I've seen HyperApp. Someone wanted me to just land that in. HyperApp. I try to remember. That one's a very small VDOM, if I remember. Where's HyperApp? Yeah, HyperApp's over here. Yeah, here's HyperApp. Interesting, but you can tell actually from this that HyperApp is not a small VDOM or innately, because these update performances suggest that they're doing something here. Most VDOMs kind of look like Preact does or React does. This suggests that the fine-grained updates in HyperApp are actually fairly performant, which suggests that they're probably doing something special here. Okay, so, okay. Where was I? I was going through the release article, but yeah, so this is really cool optimization because you can do some stuff. So let's actually pull out some code for a minute, because I want to show you. I actually implemented the JS framework benchmark. As I said, I'm not going to show the results here because the memory leak is really unfortunate. But the coolest thing about this was I didn't copy. See, this Preact one is a little old. I updated the dependencies because I was playing with it. But this is like class component, like it was written in Preact 6 or something, like .es6.js. That's telling you how old this is. Right? I mean, I've never seen this, right? But like this is just ancient, right? So like this, and then are we binding the stuff? Yeah, we're binding everything. This is a really old implementation, and I was like, man, we didn't even do hooks here, which is unfortunate. I updated React to hooks. I never bothered doing it for Preact at the time. So this is my main repo. This is just like I'm a contributor here. So when I went to go make the Preact one, I was like, I was like, wait a second. What if I could I grabbed the Solid implementation. I literally went to Solid, copy pasted it, and copied it in here. And it was easier to start from Solid to do this than from the old Preact implementation. Which is good because any small performance optimizations I did, we got to carry over in terms of structure and stuff, like just minor little things. So I was pretty stoked with that as a baseline. Right? And essentially, I did one difference. I was like, should we do this globally? I was like, let's have some fun. Let's just make the state global. One thing you're going to actually notice in the Preact solution is you can just use this stuff directly here when it's global, but when you use it inside a component, you actually have to call use computed or use signal to let Preact handle it like as a hook. Because basically it has to be prepared for the potential that the whole component updates or that the fine-grained thing updates. It needs to handle both scenarios. And for that reason, I was just like, you know what? I don't want to get into a contention argument about what's the most idiomatic way to do it. Everybody puts it in the component. I just want to see what the results are. So I just made it global because honestly, top-level component, like in a reactive library, the top-level component never runs again anyways. So like this is like potatoes. I don't really care. Oh, right. Later. Sorry. Okay. Let's get that out of the way. But essentially, the most naive approach to this is you create a signal for the list, create a signal for the selected state, and then we just update it. These are the things that, like, how you build the data, add, I just appended it. The thing you notice is that their signals work like solid signals. They're immutable changes. So even though this has like an assignment type syntax, you don't want to go like value.push. So we're still actually doing array spreads here, and top level immutable cloning, not deep immutable, but well, actually in this case it's deep immutable. This is a very simplistic version of it. And then update, I go through and I add a bunch of checks, and I, these are just array operations done in the mutable way with these signals, because the whole list is one signal. From there, I just map over the value. See, now it's dot value instead of whatever. And it's basically normal Preact from this point. We have a signal triggering the change instead of use state triggering the change. And inside the row, I just, calculated something and put it in. So I'm actually not using the optimization in this first version. Yeah. This is a thing that I used to do a lot, and that's why I copied it from the my old JS framework benchmark. I was a CoffeeScript developer, and I freaking hated having to write const and var all the time. It just like drove me nuts. So I started just like doing this thing where I just go like const and then just be like, okay, let me do all the variables. Probably drives people nuts, but I actually don't do this style anymore. But it just made for me, it just got rid of a bunch of noise. It was so hard to, you don't believe how hard it was to move to JavaScript from CoffeeScript, like when it was like just like everything was so minimal, and then like to move to TypeScript, I mean, whew, like it felt like taking 30 lines and making it 150. Like that never feels good, even if you get all the benefits. You're just like, it's like 5 times more code. It was like so brutal. It's like a gut punch. But it's fine. There's a reason to use TypeScript and whatnot. But anyways, this approach I ran, and it barely used reactivity, and obviously it was just slightly slower. So I was like, okay, what can we do to make things more optimal? Well, the first thing you can do is here in this class name. See, this is an expression. And if you just pass this expression in, even if I put it inlined it in here, even if I did this, let's just do that. Preact is still going to go, oh, value change, rerun this component. So what you do instead is you go use computed. And now, suddenly, and you do it from here. Now suddenly, essentially, our selection, instead of rerunning the component, only reruns the class name, like the class on the table element. And this is kind of cool, right? And I was like, okay, I saw the performance gain right away on this one. The thing is, I was doing everything in piecewise, so I wasn't running everything to see the impact of that, because use computed actually slowed down the other things, because now we're creating computed per row. But it was really kind of cool to see the impact here on the performance, because I'm going to pull up JS Framework Benchmark. That's the change where suddenly, Preact 30 here suddenly starts looking like views 20. All you had to do was essentially start with signals and then make sure that this is the computed signal in here, right? So this was kind of cool. And then, but I was like, can we do better? Because the partial updates were still not fast enough. So I actually, the version that I ended up benchmarking was actually kind of cool. I actually used the computed that I did, but I was like, if you look at this benchmark, it generates a bunch of data, and we have this one signal. So what I did instead was I created a signal, and this is how solid works in this benchmark too, a signal per label per row. And then now row.label, instead of re-rendering the component when you update every 10th row, like I showed you here, where is it? Not there. Where's my local host? Yeah. Actually, and we can actually probably run this. Preact Signals. Yeah. Essentially, when I update every 10th row, okay, this is in a broken state. Sorry. It's because I've been messing with stuff so much. Let's actually... let's rename this one to rename main naive. Well, VS Code is not happy. That was the slowest rename I've ever seen. Let's rename that to main. And let's npm run build prod. Okay. If I did this right. Yeah, there we go. We're back. Okay, so essentially now when it updates those exclamation marks, it can actually do it, just update the text nodes for those individual ones, which is really quite cool. So this is kind of patterns that I was talking about, because once you kind of get into this zone, you can start nesting reactivity, and those two changes actually significantly improve the performance onto those benchmarks. The challenge is balancing that with the new overhead of creating the use computed and creating a new signal per row. And this was a challenging one for Solid. I spent so much time optimizing memory profiles for reactivity so I could get that kind of performance. And one of the things that I thought was really challenging here is that this is an interesting zone to be in, because I'm trying to think of the best way to phrase this. Like, in order for Preact to know to do the optimization, you have to wrap it. Remember I was talking earlier about how Solid just uses functions because we didn't want it to have unnecessary wrappers. But for this approach to work, you actually have to both wrap the expression and then wrap the pseudo component. You're doing like a double wrap. And now Preact probably has a way to optimize the double step there, but this is sort of the interesting thing here, because you have to be very deliberate in order to do this choice, right? So this is kind of like, there's a little bit of a trade-off here. Hard to choose what's more important, creation or update. For SSR creation is what you want. For client side, probably update. Well, it's hard to say. Like, navigation on the client side, like a single page app, is mostly creation. Like, Reacts came into popularity and VDOMs came into popularity because how fast they were at creation. Old reactive libraries are really bad at creation. So there is like an interesting line to follow here. Yeah, I mean, I can talk about that in a minute, but yeah, what's interesting about this actually is that it's a runtime approach with reactivity, right? But I think you guys are kind of getting where I'm getting at. In general, huge ergonomic improvement, and then essentially you have this ability to do these little updates. I think the challenge here, actually, looking at this and working through it, is, remember when we were talking about lists and keyed lists? I mean, if you go all the way one paradigm versus the other paradigm, you're probably fine. But where were we? We were talking about keyed lists here. Remember this? When you do key with immutable changes in a VDOM, you actually dig deeper. When you do ref, like you do in a reactive library, you don't want to dig deeper. And these things are kind of at odds with each other if you do a hybrid, because if you go deeper, you end up recreating the component, which means you take on the hit of the reactive overhead if you do it half and half. But if you rely purely on reactivity, then top-down changes won't ever propagate. So like you kind of got to go one way or the other. And the challenge here is like think of how Preact maps stuff. Like think of this. Okay, this is a map function. So the second that you actually update data.value, let's say add an item to a list. This is an example of a change that isn't contained in here, right? You need to run the reconciler, and I guess the key to this whole thing is, besides there being a key, is that essentially when you hit a row that's unchanged, not to recreate all this stuff. So which means that every component that has a subscription now has to have that auto memoizing mechanism built on top of it. It's just interesting here, right? Because most frameworks that work with reactivity and enforce reactivity have special helpers like Solid's for component or directives and stuff. They don't just do a simple map because of the difference between this behavior, and because you don't want to map over everything essentially every time something changes. You want a smart memoized map. But memoization is not free. So yeah, this is a challenging place. Do you know what I mean? Like, I actually did talk some. This is a good question. I gotta cue these. We'll go back in a second. I want to finish my thoughts on Preact signals here. I don't think this is the end of the story here. I think that people will play with this, and I think they will, like, on one hand, Signals, the state library for Preact, seems like a really awesome MobX like thing, and I love this paradigm. I'm super stoked to see people using Preact this way. Preact Signals, the performance optimization, I think is going to be a very hard sell. Like, I think this is actually, like, we're seeing already these sort of challenges because you can opt into very specific optimizations, which are nice, but then there's other side of the trade-off because the models are actually different. And views actually, I think view is where the source of the solution is going to come from. I think if you look at what view has done, they've changed their VDOM to actually respect reactivity so that they can account for these little sort of differences in terms of like thing. But the thing is with Vue is they're all in. If you don't use reactivity, you're not going to get your updates. You don't get to play half and half. And this is a challenging place to be because the value of this is you're like, oh, it's like reactivity and all the good stuff, but React compat. Like we still get to use React the way we always did. So I don't know if Preact would follow that, right? Because like having React compat is a big deal, you know? That's the problem. All the rest of us, like Vue didn't go that way. They went all in on the reactivity and they came up with their own syntax. No React compat. Solid was like, no, reactivity is the thing. No React compat. Preact has the ability to kind of teeter both lines. And I think that's the win. I think the takeaway from this thing is really ergonomic. Get to use all your React stuff. It's sweet, but this is not a performance thing. That's like you might be able to like update like a text node somewhere, but like you need to like there's a structural architectural considerations here. The same reason why Vue Vapor is not going to be compatible with Vue. Like you don't get to have it both ways. Basically. So yeah, I think this is going to be really interesting because the exciting part is going to be a whole bunch of new people using reactivity and understanding just how great it feels to write stuff this way. In a sense, Vue's been doing this for years, but now there is now it's like in the JSX land. So you got like some people might have heard Solid and they're like, oh, Preact's like this, and you like it's changing the dialogue. And it's interesting because in this world, it's actually React that's the odd man out, if that makes any sense. like there's way more reactive libraries than non-reactive libraries. In that sense, I feel like we should preserve or protect React from this to a certain extent, because I want to see them take things as far as they possibly can. It's weird when the most popular library is actually the odd one out, but I don't want, I want to see where they're going, because I want to understand how they can do this stuff completely differently, because almost everyone else has kind of come over to this side. So, yeah, right? Like this is a very interesting thing. As I said, the whole space is a spectrum. It's a range. So I think it's really cool that Preact has actually found a niche that's in a different space. Because I always look at these as like those two grid things where you're kind of like, you know what I mean? Like it's like the quadrant grids, and you're like kind of like seeing how everything positions. And I think Preact has managed to find a way to step out of React Shadow in a really, I think people are going to love this, is what I'm trying to say. Okay. That's my Preact kind of rant. As I said, we'll have benchmarks in a few weeks. I'm I'm pretty confident in what we'll see here. I don't, as I said, I know I've seen some stuff and I've got the PR open. I know those are not the final results. Don't go run them locally and then go do some crap with them. That is not how this turns out. I've got a sense for this stuff, and I think it's going to be actually interesting to actually test the different versions and then figure out, like, from a micro thing, like what the critical point is at which one approach is better than the other. Like, is the overhead of the computed worth it versus the other? Is the nesting worth it or whatever? And as I said, this is me as a framework author, kind of playing around and trying to understand these boundaries, because that's the kind of tweaking I did in early days of Solid to understand why components as the boundaries weren't the right boundaries. So I'm looking forward to seeing how where that goes. Yeah, and yeah, this is a really good point. They released a React version, so you can use this in React too. This is like the perfect Trojan horse. As much as I might have come off, like, I got to lay it to you straight, kind of going through this stuff, because performance hyping on Twitter without benchmarks to show it is one of my pet peeves. Like, I need, like, don't release something and talk about performance and don't and release the benchmark. So I need to talk about this. Like, always, benchmarks aren't perfect, but I need to have it. But on the other hand, this is so freaking exciting. Like, like, I'm just picturing this, like, a library of the popularity of Preact and so closely in React space. Putting this out is such a big message, and people are going to be trying this stuff and they're going to love it. Like, this is so exciting for reactivity and reactive programming. Like, take whatever I said about, like, I'm talking about benchmarks and performance gains and little things here, you know, because that's what I do. Overall story here is enabling people to do, like, author apps in new and different ways. And I think it's not even that different, but, like, just improving that quality of life. And I think that is such a huge win here, that the mindset, the mind share, the whole thinking is going to evolve because of this. This is a huge moment in time, if I haven't made that clear. I focused on the nitty gritty here because I wanted to understand the technical aspects, but this is very exciting. And the fact that React has this ability, like, there's already React state libraries, like React MobX or whatever, and React Solid State. We can use Solid in React. Someone asked me earlier if we could inline the, like, use observer. I'm not sure, but if we did the same trick to hijack create element that Preact does here, probably we could. But I mean, or you could just use this Preact library. It's more popular. I haven't benchmarked the difference between the reactivity. I mean, it might not matter. You know, as I said, you're kind of subject to React's own system. Preact is already so much more performant than React in, like, a lot of the more typical scenarios, that, like, it's not, like, who knows? The reactive system overhead might not even be a thing. So yeah, I mean, if people like Solid's APIs, we could look at seeing if we could do the same optimization. I don't see why not. You can always use Solid with React, but the fact that this is so seamless, with Preact and React with this adapter, is really the game changer here. It's an ergonomics thing. As I said, it's like the perfect Trojan horse. People are going to start using this and then be like, oh, yeah, it's interesting. I'm like conflicted because I think this is like a big win for reactivity, and that's a big thing I care about. But on the other hand, I I want to see, I guess React doesn't need my help. They're the most popular framework out there, but I want to see where React's heading because I think they have a different model that's innovating in a completely different direction, and I want to see that direction. Okay, so let's address some of the stuff in chat now. Can I highlight re-renders so you can see them? Okay, first thing I want to talk about here. All the systems do pretty much optional DOM updates. You're never going to see the re-renders in React or Preact or VDOM. Even if they do too much work, they don't do too much DOM work. So like a browser paint flash won't work. You need like a dev tools or something that hook into the component tree to do this. So yeah, I don't have an easy way of showing the re-renders because by the time it gets to the DOM, it's pretty freaking optimal anyways. It's the other overhead that we're measuring. Okay, let's talk about React Forget and compiler-based approaches for memoizations. I mean, I'm trying to think of the best way to put this one out there because I actually, if you've been watch any of my recent talks, I've addressed this specific thing. Memoization is great, but it doesn't change the fundamental problem, right? You just get a crazier compiler. I mean, I guess I haven't shown this on stream, and I've been doing so much stuff recently. Let me see if I can grab one of these. Which one do I want to use? Reactivity Unchained, Streamlined. Okay. This is from one of my talks, but I want to talk about this one because this is actually from the React Forget video that we're talking about here, and they show this to-do app, and they show the exact problem Rich Harris showed in his article, where you have state that updates that's not necessarily related to the to-do. Here, it's just the to-do stuff, but what he points out in the video is that, like once you have like theme and visibility coming through, you suddenly have React memo and use memo and all these things. This is inherent to a model where you have to rerun the components. So all you end up with is a compiler that outputs a whole crap load of things, all these memcache checks and stuff. So yes, you can, you don't, this compiler might be able to optimize things a tiny bit further than what React does today, but this is an ergonomics thing. This doesn't change how React runs. This just changes you from having to write the use memos. I think it can go a little bit farther than that eventually, but because once you make the change, you no longer can keep the same mental model, which was what I was talking about on my last stream. So I think this can also be a launching point to other stuff. But what I'm getting at is it doesn't fundamentally change this top-down thing. Whereas Solid's fine-grained updates that aren't component-based, and even Preact's kind of little trick here, for the specific updates, does do that. It stops the re-renders. It's possible that React can try and figure out a way of zoning in on that, but the trick is it's got to persist across components, and Preact's way of using observables or signals or whatever to pass it through is a way to do that cross-component. If you're just using your components state management where like use state is tied to the component, you can't really do this easily. Like you need the change to come from outside of the component in order to make a subcomponent to do the change on, right? I hope that makes sense. So while it remains to see how like this trade-off works with Preact, and if they introduce more primitives to allow you to do better fine-grained stuff, like Solid's 4 component, like whether that's in the future or whatnot, it is still in question. The compiler doesn't and at least initially, trying to keep React the way it is doesn't change anything from how React runs. It just changes how you author it. Wrapping reminds you how quick behavior splits each attribute dominant components. Well, yeah, there is similarities here, but the whole idea, and this is the whole point of this stream today, is that components, being that change, has the limits to it. What Preact is doing is very clever because they've found opportunities to optimize by making like subcomponents. I don't know if that can actually solve everything, right? Like it does enough, but I don't know like if subcomponents could actually work everywhere. Like to have like a component, like a nested smaller component. I realize using the term subcomponent isn't great because I also use that to talk about Quick when I say it's subcomponent, and the fact that it splits a component into multiple pieces. But in a sense, reactivity is what does that. Quick is doing it to a VDOM because Quick has a VDOM, which is why you can kind of pull the similarities to what Preact is doing here. Whereas you can do it even more fine-grained if you wanted to, if you use the reactive graph, essentially. The way, so like in a sense, it's like Preact is to Quick as Solid is to Marco 6, if that makes sense. Like the ability to like go even more granular. So yeah, it's an interesting thought. But yes, the takeaway here is components are too big, and components should be kind of for end users to decide how they want to organize their code. And conflating code organization with performance and runtime execution is a mistake. That's my argument. Any code without memoization might work better than with it. Yeah, the same idea. Okay, here we go. I remember Dan Abramoff saying that React is a pull model versus Solid's push model. I mean, they can schedule renders. Do signals break React's pull model? Yeah, and this is the concern here, right? I showed the quote from Dan earlier, and he's got a bunch of them on Twitter. The concern, because React wants the ability to re-render concurrent separate trees at any time, like separate versions of the same tree. They like the ability that they can just plug in the state and just pull it out at any point. Go like, okay, here's this state gives me this VDOM, this state gives me this VDOM, these VDOM. If you have something that kind of persists, because if you think about it, the signals in Preact, if you nest them, you don't want to be like recreating them necessarily. Like you want to render less, kind of like Solid, kind of like that kind of zone. It becomes a lot harder to just pull the values. That being said, a specialized reactive system could handle this, right? I've shown this before. That's on previous stream of 1.5 stream. That Solid has a push-pull system. Essentially, we have the ability to basically propagate the change without running it and scheduling it in a queue and then running that queue afterwards. So that's why Solid has concurrent rendering and all that kind of stuff. So in theory, you could do the same thing probably with a reactive system for Preact if you wanted to go there. I mean, it's complicated because we use the reactivity for the actual rendering system. So like it's all part of the same thing where we still there's still this VDOM versus reactivity game going on when you're kind of trying to do both. So in a sense, yes, but then you could achieve it in a different way. But this is why React is not going to go this way, I think. Once you're doing data value, you have to opt out from reactive runtime. You're back in React mode. Yeah, it's interesting, right? Because it depending on how you opt out, you might actually be worse than being back in React mode because now if you're not careful, you actually end up remaking the reactivity on every render, which is more costly. Am I afraid of winning too much? No, I mean, ultimately, I think I'm happiest about the fact that to be part of something where I was a catalyst in making change. Like Rich's work on compilers is another example of this, or even some of the stuff that came out when React first came out. I feel like the change we're going through right now, and it's funny because like I see it all part of the same thing where like obviously every framework sees their angle is unique and they're the special ones or whatever, but every part of this is part of this. It's a sign of components as runtime being not where we want to be. Whether you're talking about Quick, the Quick guys like to talk about generation 1, 2, 3. I'm not ready yet to say what generation 3 is, but I am very happy that my work has been instrumental for people understanding this. Um, that it's when stuff like this, like obviously the Preact change had influence from a lot of other places too, and like Ember, they've been working on reactivity forever, and there's so many things. But the reason the conversation is happening right now has a lot to do with the shakeup that's been going on with Solid, and I think that's incredible. I might be like far on the far edge or on the wing, being like, you can take it all the way, but you don't always have to take it all the way. I'm just happy to see this mind shift where people can recognize it, right? It started for me because I liked the ergonomics. I liked building apps this way. And then it got into benchmarking, right? And you might think, oh, well, benchmarking, that's something where you can feel some sort of accomplishment. But this is much greater than that because it leads to people adopting, like it changes the way people build apps and like actually where they live. Solid's been like at the top of the JS framework benchmark for like what, almost 5 years. Like 5 years ago no one was talking about it, not many people. Like that metric was fun, but that's not the end of that's not the be all end all, you know what I mean? Like in the grand scheme of things, being the fastest framework for 5 years doesn't matter, but having changing the paradigm from where how we build apps today to how we build apps tomorrow and being a part of that's amazing. Sorry, I'm just still catching up on chat. Seb made an off mention of wanting to do something like signals on React. Do you think it's more ergonomic? I do. Then hooks, I do. I think hooks are really smart, but it's kind of like how I think computeds are easier than selectors. Like push and pull are completely analogous. You can have like the same thing in a different form. It's funny because I call our computeds memos in Solid because I treat them like that because we're kind of push pull. Memos is our derivations are kind of our middle ground where we handle that. But yeah, I mean, I don't know. I think this has got them thinking or talking, but I don't feel like this is their direction. I want them to stay the course because they're taking on territory that no one else has. And I kind of felt the same thing when I saw Quick. There's parts of Quick's solution which I think are not as important as other parts, but if they're not going to explore that part of the solution, no one else is. And I want to understand. So I want them selfishly to keep doing what they're doing because there's so much to learn here, if that makes any sense. Yeah, this is fair. It's because we're talking about, React 2, React 3. I know people are like, oh, we're in React 18. We are going through that kind of change right now. And I think for a long time, like Remix is almost an example of it. They built Remix on, let's call it React 2.0, and without any thought towards React 3. And they actually rebuilt a bunch of the features that React 3 would have. And in a different way, whereas Next was like, okay, React 3 is coming, this is how we're building it. And I think it's kind of an interesting thing because they could just fork off React at React 2, so to speak, and because of backwards compat and whatever, and mostly be fine until the libraries in the ecosystem change. But when you are the libraries in the ecosystem, you are the router, you are that, you could just make it your own framework. I thought for a while that was like a real potential that Remix would just kind of like not actually fork, but effectively fork React. Like essentially just be like, we just stopped at React at this point in time because we don't believe in suspense, and we don't like that's what their message was. It was basically anything that was new in React. They're just like, we're skeptical of it. It's changed now, and they support suspense and streaming and all that stuff, and they're talking about server components. But like for the longest time, Remix was like, that's all like unnecessary. We built our own transitions. We built our own stuff. You don't, you know. And I seriously thought they were going to fork, so to speak. So yeah, it's interesting because React's going to be a competitor with itself, kind of like Angular 2 was a competitor with Angular 1. I do feel like we're entering like everything's a new framework land. It is 86 in our house right now. Yes, I am dying because it's even hotter in here. That's my wife. Someone asking about primitives. You've got to see, we are working on solid area. I don't know if our Hope UI has good, good, how good the accessibility is on it, but I do know that Devin's like actually in our Discord chatting with people, and we've been working very closely with him to get kind of a port of the React area library. Okay, I haven't read this, but I'm just going to put it up because Maple says great stuff. So let's see how I react to this. Thought, in a universe where we actually manage to automatically and predictably memo everything, you still have to do top to bottom renders, right? With a reactive system, you still only have renders that leave nodes and skip parents intently. Yes, yeah. This is talking about what I was talking about, the compiler, right? I mean, it's such a weird blend when you go super far down this path, because Marco actually, we've kind of gone both ways, like teetering this line, because it's a very small difference between writing all the code and wiring it so that it like just runs like fine grained, and that it queues and schedules sort of like a reactive runtime does. But generally speaking, memoization, or the need for memoization, suggests because you rerun stuff that's unnecessary, and that it's coarser grained, and that it's inherent to diffing. And as long as that's your model, then that's where you are, no matter how much you do. My whole premise here is that diffing, there might be cases for diffing because there's a specific optimization, but generally speaking, diffing isn't needed. My whole premise is essentially that it should be possible that anything you could diff, you could do by not diffing. It might be more complicated. We have to figure out how to model it, but thus there's always a way to make something more performant than the diffing solution. That's like the premise here from a like theoretical academic standpoint. Yeah, the share the love. Yeah, right. Everything gets better. Have I caught up to chat finally? Gotta drink some water. So hot. Interesting. Interesting. Okay, so maybe that whole area, I can see why you'd want to do this if you want to make your library work and not just React. I think this was actually kind of a thing, because when Solid came out, I talked to Daishi a little bit, and he was like, so how do we integrate Jotai with it? And I was just like, you don't? And he kept on looking, and then he's like trying to come up with it, and then he's like I can't figure out how to we couldn't figure out how to integrate it, like Zustand or what's the other one? Redux was no problem. MobX took a little bit of mapping thing, but we actually have an external source API in Solid where you can actually like take any reactive system. In fact, we should do this. we could take Preact Signals and actually use them directly in Solid JSX, because we have a way of taking any reactive system that's fine-grained, like views or solids or Preacts, and actually using them natively inside our templates. It's really cool. No wrappers or anything. You just write up the code, and then you can just go like import signal, use it, and it will work naturally as is using Preact Signals. I think that would be a fun thing to do. But Jotai was specifically difficult because they weren't a typical fine-grained system, and they weren't Zustan. They had, their system is like set up to be like write the thing, whether it was React State or whatever. And Solid had no components to rerun, so it just didn't make sense. It was interesting though, because he actually did an experiment where he tried to make a complete non-VDOM renderer based on top of it, and he got it working. But yeah, the performance was just terrible. It was very inefficient, but it was really cool to see him play with that after Solid came out. Just kind of, he's like, oh, maybe we don't need React. Jotai the framework. So yeah, it's definitely interesting. Okay, yeah. Yeah, I mean, currently each framework has its own solution. Yeah, I mean there's an easy solution. We should just stick them all in a benchmark, and whichever one's the fastest wins. Sorry. I told that to the guys in Ember when they're talking about Starbeam, because I put Solid isn't actually the fastest reactive system. There's actually criteria that are important for rendering the way Solid renders that actually affect the propagation, because Solid is a reactive renderer. There's like a slightly more consideration on terms of execution than you find in like a simple, quick 50-line reactive implementation. So like I can't, even though I made MobX JSX and Vue JSX, I don't know if people remember this or are aware of this. I actually took Solid's renderer and just plugged in a different reactivity in it. Now that Preact has what it has, I should do that. That might be fun. We could see, because I told you about how Solid can take any reactive system, but that version still uses Solid to trigger the change. It's a little bit less efficient. We can just take Preact's reactivity and stick it straight into Solid's renderer without Solid in the middle, and we could see how performant it is. But yeah, it's difficult. It's not just APIs. Like I sometimes joke, like I made an example where I called it Vue-like, where I wrapped Solid in Vue's APIs so people could just like use Vue's syntax if they wanted to. Like on some levels, the changes are superficial, but actually deeper down, there's actually execution considerations, slight variations on the push-pull, and some of those are actually really important to Solid on how it renders. It's like part of the requirements. Solid has features like its reactive system handles concurrent rendering. Like it actually ingrained in it. It's part of it. It can actually, it's the thing that suspends. So like, yeah, there's a while ago where someone's like, oh, don't use a framework, put it in a reactive library, and then you can just switch which renderer you want. You can suddenly go between Vue and React or Mithril, love Mithril, and just like take, or Lit, and just take your reactivity, and that's your app, and then you can just change your renderer as renderers change over time. And I kind of laughed at the thought for a minute. I'm like, you guys just replaced what the framework was. You've made the state library the framework instead of the Vue library. Like that's the piece that you won't be able to get rid of. Like you're locked in. They were trying to say that they weren't locked into a framework, but I'm like, no, you're locked into your reactive system. Ultimately, I think that's a nicer place to be to a certain degree, except for the fact that we talked about today is the change management of the framework will always be more optimal than the state management that you add on top of it. Always. So at a certain point, for all the portability here, it collapses. And I think that's actually what we should be, thinking about or whatnot, because as much as I'd like to say like, yeah, let's all use the same solution. Like I tried to do that with my renderer with DOM expressions. In the end, when you're all trying to do the same thing, exactly the same thing, like that's the goal, you might end up with a single standard, like a single thing, like solid is the best DOM expression library. That's an example of it. Astro's the best, or solid's the best Astro Island. That's an example of it. Okay, I'm kidding about that, sort of. But you know what I mean? Like, and what ultimately ends up is you actually get other fracturing where they're like, okay, you took this general solution, now it's actually become a specific solution because it's tailored to a specific need, and that's the way you're attacking it, and it's the obvious choice. Something else will fork out and be like, no, that standard. That refinement process is a good process, but it also leads to just more things to fork out because something else becomes important that solution didn't take it into consideration. And as I said, the wrapper becomes the framework at that point. You've just changed what the framework is. Oh, yeah, sorry. You actually said the argument that people make, and yeah, okay. That's my answer to it. What's your general thoughts on type splitting? Is React model the best or only way to accomplish it? Is it the best way? Maybe. Is it the only way? Definitely not. I mean, we have time slicing in Solid. I've shown it how it's possible. I did it on stream, unfortunately, and it's such a funny stream because I'm sitting here on my computer and everything looks like really smooth, and I'm like so proud and like it's one of those smug moments, I have to admit, because Paul Henschel kept on being like, "Oh, you just need a VDOM," and Dan and everyone just keeps on going, "Oh, you need a VDOM," and I'm like, I watched the stream back and the video chops, like the way I'm screen recording, not using OBS or whatever, couldn't keep up with the animations and it all looks choppy. So I'm sitting there acting all smug and being like smooth as butter. And like the video is just like the worst, like choppy bit, and it's kind of embarrassing. But I think that React has a good way of approaching it. I do not think it is the only way. However, I don't think you can just jam reactivity into React's way and be like, it work. I think you have to stay true to your model to find your way of modeling that problem. So it's not like the only way, but the other way is going to be quite different. Yeah. Jotai JSX. Yeah, this is the experiment I was talking about where he's making his own framework. Are there reactivity benchmarks anywhere? Great question. There's a few. The ones I use, I use different ones, and they all show me different things, except for that Cairo is the fastest reactive system that exists. Kairo. But essentially, Solid has a reactive benchmark in our repo. CellX has one as well, and Cairo has one. And I use those three to do the benchmarks. But each one has slightly different characteristics. Like CellX doesn't work in most of our benchmarks because CellX has a certain async element to it, which kind of cheats it. So we can't usually benchmark it for most things, even though it's one of the fastest reactive libraries. The CellX benchmark is just like a big mess of jumble, so I don't even know sometimes what to make of it. But it's good because I can always see if I make a regression. So that's why I use that one. And then the Cairo benchmark is really cool because it has a whole bunch of different shapes of reactive graph propagation, and we tested it. So yeah, I do a decent amount of reactivity thing. I know Solid's not the fastest, and I actually, there's a bunch of optimizations that I left on the table because it made the code size larger, and I was just like, you're never going to see this in real thing. Like if you're not going to see it in something like the JS framework benchmark, you're probably never going to actually see it. Like there's reactivity overhead, there's DOM overhead, and then there's like end user code. And the thing is, the JS framework benchmark will show you DOM overhead because it's like huge amount of DOM, but it basically uses like slowdowns to amplify the framework overhead, which would be the reactive overhead. If your reactive overhead isn't overcoming the DOM overhead, you're not going to see it, and it's not going to matter. Reactive benchmarks, it's very easy to be like, oh, the system's like 30, 50, 100 times faster and have no impact at all real world for most things because it's not enough to show up on the DOM overhead. Finally, in the end user code, I mean, that's the constant between all of this. And the only benefit the biggest benefit you get of reactivity is making that stuff fine-grained. You're basically limiting the scope of what the end user can impact the performance of the app. By going with reactivity, you're like, okay, when they write the code all in like separate effects or memos, you're like, okay, only that piece runs when they do some stupid expensive thing. Whereas I think with a VDOM, you do that and you're like, oh crap, you re-render hell. Like it re-renders 10 times. Like the challenge is that a VDOM re-render is not very expensive. So I don't know how to draw this in a graph, but like it's like how should I put it? Let's get into Scala draw one last time. Like if you have levels of how much you can mess things up. Like I don't know how to draw this as a graph. Like it feels like I want to do something like this. This is impromptu. I'm just thinking here, but if you have like, if your graph here is like, let's figure this out. You messed up. I want to say like there's basically different tolerances from like, I don't know if I might need to rethink of the visual for this one here, because essentially with a VDOM there's this kind of like, yeah, I guess the other axis is, this is the degree of how much you messed up, and this is the degree of like impact of that mess up. Okay, so like yeah, like not for kids, sorry. Like maybe I shouldn't write that in writing, but like when you take an approach like with a VDOM, and oh yeah, thanks Marvin. I am wrapping up here. You haven't really missed anything, but thank you for joining today. If you go with a VDOM and you talk about like impact as being like how terrible things are, it kind of looks like this. Oh, can I draw? You get pretty steep pretty fast, and then at a certain point the VDOM just kind of, God, my drawing is terrible. At a certain point the VDOM kind of levels it for you, kind of like that. So this is our VDOM. With reactivity, it's kind of like this. It's like you're like smooth cruising through here, right? And then like even when you mess up, it still stays kind of linear. And then it suddenly does this. Like it's almost like a shelf. It's almost like my free drawing is no good. It's suddenly like, and when I say I mean like remix off the end of Zach's 11D graph. This, like, I mean like this is still going here. Like it's this is sort of the difference between these approaches. Like there is no safety net, and you hit it here on a reactive library, it's like it's suddenly exponentials off, and then you have fallen off a cliff. A VDOM will never let you fall off the cliff. Am I trying time slicing? Right? VDOM will never let you fall off the cliff. It'll just basically kind of eventually slow the bleeding. So I do think it's important to note, because usually what happens with reactivity is you start in a good place and you're like, sweet, this is so much faster, so much better, blah, blah, blah. My components aren't re-rendering 10 billion times, da, da, da. And you do some stuff and you kind of like messed it up a little bit and who cares? And then you get to a point, and maybe this line's like a little bit sooner than I drew here, like a little bit more over this way. You get to a certain point and then it's like, bam, you're like, holy shit, what happened to my app? It's done. Like, and it was one thing where you just completely messed it up and now your whole app is like doing crazy re-renders. My whole work, what is the x-axis? How badly you screwed up. No, it doesn't matter, because reactivity doesn't scale the same way. It actually scales really, really well, which is the thing, because it's all modular. It's about how badly you screw up. So my whole work with Solid, if you want to understand what I do daily, is this arrow pointing here, pushing the stuff this way, like two hands. This is Ryan right here, pushing that line back. I do everything in my power to push that line further back. Because in knockout days, that line used to be like here. MobX moved the line this way quite a bit. Solid's moving the line this way too, but this is a reality of it. It's always easier to just be like, oh, okay, I got my VDOM safety net. But until I could push this line this far, this is why people weren't talking about this, because at a certain point in the past, it kind of felt like the wall for reactivity was right here. Like, you basically, the second you messed up, or even things, you didn't even have to mess up for things to mess up. like that was the feeling with reactivity, especially with magic and all that stuff. So all I've been doing is pushing this line back. And that's kind of like a way of looking at my work. Yeah, impact of making mistakes. Yeah. Yeah, because like, to be fair, like, there's like, when I say you messed up, I mean you it should be more like you really messed up. And like here, this could be like you made a mistake. Like, the thing is, like, I find reactive libraries, because of how modularized the changes are, they're more forgiving until they're not. Time to infinite loop and knockout is a few hours. That's a good metric. Yeah, but see, the thing is, for getting a function call in Solid, for the most part, just means it doesn't update. So you screwed up, but it didn't impact your performance. It just didn't work. Like, that's why there's so much guards. But picture, an example of this is Solid's components on track, okay? Let me show you via code what I'm talking about. Picture an expression in the JSX like this, okay? Where it's like condition, and then expensive component, which is funny because Solid's components aren't expensive, but let's pretend it's expensive component. Otherwise, no, okay? And this expensive component takes some props, okay? Now, as anyone who's followed me knows, that this thing gets basically transformed into create effect. And essentially, I mean, this, right? And instead of this, we're just gonna do this. In this case, we can just pass the prop straight through. Okay, that's why I did the spread, right? It turns into this, okay? But I often say that solids components are just a function, but there is one key difference. We untrack our components, and this is why. Because if someone in here, in function expensive component, went, ooh, I need this, or not this, I need some value, and I need another value, right? Someone did this, and then they're like, yeah, do stuff with value, another value. Okay. Do you see the problem? The problem is if solid didn't untrack this destructure, right now in solid, this destructure means nothing's reactive. This never updates again. But if solid didn't untrack, this destructure would trigger this effect, the parent effect, which would cause the component to re-render every time. Like essentially, if value or another value changed, it would redo all the expensive stuff every time, because essentially we're registering these with the parent effect. So in solid we untrack. So when you try and access something outside of reactivity, it's just like, that's not reactive, you messed up. But if we weren't careful to do that, you could do some pretty terrible stuff, because you could kind of butterfly effect. Because I mean, what if this effect read stuff up, and like it's possible to actually like redraw huge portions of your component tree if you don't guard yourself. I did an incredible amount of work to make sure you don't screw up, but Knockout did not have these guards, and you do something wrong and it'd be like, oh, it looked like it was working, but you're actually like recreating all the DOM nodes in front of you multiple times sometimes. It was kind of crazy. But yeah, I want to be very clear that this is not a scale thing. Theo had a very similar drawing where he's talking about cliffs of scale. This is not a scale thing, because it's not directly a scale thing, because this is about how much things are screwed up. And the thing is, if you do a bunch of small screw ups, they'll be relatively isolated in a reactive system where they aren't in a VDOM system. So I actually think the scale is good. It's just like, yeah, it's one of the, yeah, anyway. Yeah, we actually did talk about this for a bit, for about an hour ago in the stream, I guess. Basically, it's a good way of making a state management library feel first party in a VDOM library, which is really incredible. That's kind of the takeaway. It was a little different than Solid, because Solid is a state library that happens to render. So it's slightly different. It means that for Preact, this is mostly about ergonomics and making things easier to use and feel nice and letting people write better code. And in Solid's case, it's very much its thing. It's like its existence. It's what makes Solid what it is, gives it all its performance, does everything. So similar looking, very different when it comes to how they actually operate. Yeah. I'd rather render too often than render too little, but you know me. Yeah. But this is the challenge, right? Rendering too often without a VDOM safety net or a diffing mechanism is actually a death sentence, like a much worse death sentence, the VDOM. So, I mean, I just understand this graph, because when you're living at every point until you get towards here, you're just in a so much better place. And this isn't just again, easiness or a scale thing. This is like this. Yeah. I mean, there might be a factor here kind of like failure factor. Like if you've ever done failure stuff, like I'm an engineer by trade, and you basically have to do a bunch of math to figure out what the rate of failure is. And if it's not as linear as you'd expect, because like it's often compounding, and you end up using like, inverses for doing the statistics to figure out the number. I feel like you could make maybe that argument here with enough independent failures, you can cause the whole thing to go down. And that's only at scale, that's only a projection of that math. But I mean, at that point, like, I don't know, I feel like the whole time that's happening, you're watching your VDOM app get slower and slower and slower. And in Solid's case, the fix might be just to fix one point in the puzzle, like just fix those points. I mean, yeah. Anyway, is there Solid alternative to React Native? People are playing with some stuff on top of native script, and actually even on top of React Native. I don't know what the state of that project is, honestly. I haven't kept up with it. I know there's experimentation, but I can't say like here's the docs. There's nothing that far along. I think, I think it's going to be a bit. We just need. This is one of those chicken and the egg catch-22s. We just need more investment in the ecosystem, and as we prove ourselves in each area, it will happen. But it just takes time. My focus has been on kind of core web foundations, SSR, and that stuff. So I haven't really looked too far into that, but one day. Yeah, I actually think these statements are both true. Forces you to fix your code when it breaks. So if you do something really bad, and is strictly better in the meantime. Yeah, that's my position. The Solid puns write themselves. Yes. Solid alternative. Yeah, you guys are good. I don't know. Any more questions for today? This was this is basically what I wanted to do. I'm streaming again tomorrow, and we're gonna get into like language stuff, which isn't always my favorite topic, but I think it's actually really interesting because like a lot of work goes there. I try and dodge this with Solid all the time because I see how much effort goes into these things, and it's like, God, do I want to spend like months working on TypeScript language servers and all that stuff? But if you want to understand just how hard it is to go build your own language and see what power it unlocks, like the trade-offs in full scope, Dylan's the guy you want to talk to. He's been working on, like, Svelte got into the compiler business really strong in 2019. Marco's been doing it since 2014. They have, and they're even more ambitious, like this is the guy you want to hear to understand like what it looks like to build your own UI language, as a framework. How important is UI? I don't know. This is an interesting one. I don't know if you're asking me, Fabio, but this is an interesting question. I've hit apps that have maxed out, but that's because I was doing crazy stuff with image processing. It does tax the device. I've focused on memory a lot because that's the weakness of reactive systems. If you address the memory, you address the slowdown, and that's you, as you know, with Voby and whatever. You fix the memory, you improve the performance. That's the key thing. But in real apps, unless there's a memory leak or it's getting away from you, it's hard to say because it's one of those device restricted constraints, and people have measured stuff like load times based on bandwidth and CPU, but memory rarely gets talked. I don't have good numbers here. My gut is the difference between a framework that's the same memory or double the memory doesn't matter until you get to a certain point. But I don't know that it's not it. I've optimized memory because creation is the weakness of reactivity. So you focus on memory because you want to make sure your creation and removal's fast. But I don't know how important it is outside of that. Okay. Anyway, yeah, I think we're done then. Thank you everyone for joining today. I had a lot of fun. This was, as I said, a topical topic, and I knew that, like, look, we've been here for like 4 hours. I knew, like, this week in JavaScript, I couldn't like talk to Dylan for 3 hours and then do a 4 hour This Week in JavaScript. We are going to do a This Week in JavaScript tomorrow, but like, yeah, this topic and these things need to be talked about. I'm very, very excited in general just to see these conversations happen. So yeah, I mean, this is going to be really exciting moving forward to see more and more people looking at reactivity, which is why it's important to understand the differences and how they play together. So I hope we accomplished that today. Yeah, thank you all for joining me, and yeah, see you tomorrow.